हम्म, हम्म, हम्म। हाँ, लोग पार्क में बात नहीं। अद्विता देश पांडे इससे। हम लोग का भी मतलब वो प्रेजेंटेशन है तो उसमें नाम नहीं है हम लोग तो सृजनी दी बोले थे कि मतलब आप लोग दे देना लास्ट में नहीं तो मिडिल में नाम। हाँ इसमें नहीं है। तो आपने सबमिट किया है? सबमिट किया हुआ कौन सा दिखा रही है? शुभम को मैं ये हाँ शुभम को हाँ। ना तो आपका इसके बाद रखे तो आप देख मतलब एडमिशन देना अगर सेकंड कौन है? ये तो शायद आपने कल सृजनी मुजुमदार है। और कोई है आपको प्रिंसिपल इधर नहीं नहीं नहीं। ओके थैंक यू। हाँ। Hello everyone. We will start about 5 to 10 minutes. Sorry for delay.
Hello, everyone. I know very less people expected, but the stars are here. Aritra, Anamitra, can you hear me? But you'll be able to hear me, right?
Yes, we can hear you.
Yeah, okay. Okay, so we'll first start with Advaita Deshpande, who also happens to be the winner of this track. So, Advaita, 3 minutes.
Hello, am I audible? Okay. Okay. Uh, Hello, good morning, everyone. I'm Advita. I'm a student at IIT Goa, and I'm doing my BTech in mathematics and computing there. Today, I'm presenting my paper on classification of code and comments in a machine learning framework. So the main objective of our research was to use a data-driven approach to improve software documentation by identifying meaningful comments, ultimately aiding developers in better code comprehension. So comments are a very vital part of a code, and they help a lot in comprehending, but not all comments are useful. So what our goal was to classify comments as useful and non-useful using machine learning methods. We had a given data set that we used, but since it was not very diverse and the size was pretty limited, we augmented it using ChatGPT, GPT 3.5 Turbo. And so this enhanced the data diversity via LLM augmentation. So the method I used for this was logistic regression. This is a supervised learning method. What we did is used a sigmoid function to predict probabilities, and then we set a threshold uh, to classify them as useful and non-useful. Since this is basically a binary problem, marking 0 for non-useful comments and 1 for useful comments, logistic regression is a pretty effective method. So the features that we used here were just qualitative features and structural features like word length, comment length, position of the comment in the source code, ratio of significant and meaningful words in the code. For logistic regression, these were the features used. Now, these are the results that we got. We added 540 more instances of LLM generated data, out of which 442 were useful and 98 were non-useful. Comparing the original and augmented data set, we got a recall of 0.818 without augmentation and 0.803 with augmentation. And the precision was almost same as 0.79. Looking at the F1 scores, the F1 scores are also pretty similar. Since these similar results show that synthetic data falls in line with the original data set and how synthetic data creation can help in effectively increasing data volume required for training models. This outcome underscores the importance of high quality manually annotated data in creating effective models for software documentation tasks. Synthetic data generation can help a lot with data augmentation, finding its use in many pipelines. So to conclude, we addressed binary classification of source code comments using logistic regression and found out that the augmented and original datasets produce almost similar results. The synthetic data generation can enrich dataset variety. One limitation that I thought in this was the lack of qualitative analysis. I think balancing both structural and qualitative analysis could refine the classification accuracy.
I can't ask you. I mean, I can ask you a question, but we don't have time. So maybe we'll ask offline, but awesome presentation. Anamitro. We'll have Anamitro after you and then. Yeah. Anamitro, are you there?
Yes, I'm here.
One more thing is that Advaita has already explained the task So maybe you can skip the first two slides because the task is known to everyone now. That's why.
Okay.
The methodology and the results. That's fine, right?
Yes, sure.
Okay. He's in room. Just give us a moment, yeah. We'll set you up here. Share your slides, Anamitra.
Okay, I'm sharing my screen then.
And you have 3 minutes rather. I was about to say two, but then I thought you'll hit me from there, throw a stone from Kolkata. Okay, yeah, 3 minutes.
Okay, I hope my screen is visible.
Yes, it is. You can just say the task remains the same and go directly to methodology.
It's okay. So I'm skipping the tasks and directly going to the.
Can you switch on your camera? Is that okay? We can
Okay.
take a photo of yours. It's
Yes, sure,
important.
sure. I totally.
First presentations are always special and then it gets boring.
Uh,
Are you in a okay, you are in a good environment only. That's fine. Many people are afraid of.
yeah. Okay. So hello everyone. Good morning. I'm Anamitra Mukhopadhyay, a student from IIT Kharagpur, studying computer science and engineering. I'll be talking about assessing the utility of C comments using SVM and naive-Bayes classifier. So we already know the problem statement, so I'll directly go to the methodology. So the methods we deployed are support vector machine and naive-Bayes classifier. A bit on them, SVM is a powerful classifier and it's based on finding the best hyperplane. And again, naive-Bayes classifier is a probabilistic classifier and it assumes independent between features by definition. So we have also explored that if we can augment our dataset with large language models and see how effective is that. So I basically present the results here. So SVM performs significantly better than naive-Bayes for this task, but augmentation it achieves only slightly better results. So that brings us that yes, both models exhibit some improved performance with augmentation, and improved F1 scores indicate some better identification of useful comments. So in this work,
Yeah, okay.
yeah, sure. In this work, we address binary classification of source comments using naive-Bayes and SVM models. We're using features like length of comments, position, and word ratio in the form of TF-IDF. And we are relying only on structural features. So we can also take qualitative features as well. That is one of the limitations. We're not considering semantic meaning of words and all. So in conclusion, we can say we can treat these results as some sort of baseline because SVM and naive-Bayes are mainly general purpose classifiers. So we can treat them as baselines for future enhancements. That's all from my side. Thank you for this opportunity.
Anamitra, can we have a clap for him, please? Yeah. Okay. See, I cannot ask you a question. I'll ask you offline. We don't have time today. We are running 5 minutes late. Okay. Yeah. So, anyways, next, thank you very much for the presentation, Anamitra. It was very clear. So, we might have some queries regarding how SVM behaves for unbalanced data, but we can take it offline. Okay. Now,
Yes.
Ashwin. Yes, Ashwin, you can also directly move on to the methods, and after that, Om, and then followed by Oritra. Okay. Yeah.
So, hello everyone. I'm Ashwin Gaikwad, a BTech a Bachelor of Technology student at IIT Goa, currently pursuing mathematics and computing. And 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 the work I have done is, can we predict comment quality using machine learning? And I've mainly used a random forest model. So as my colleagues have mentioned, the main problem statement remains the same, where the comments are very important in today's world. So firstly moving on to the experimental setup. In this study, a random forest has been employed. The model had to just classify whether a comment was useful or not useful. So it was a 0 or a 1. So according to me, a random forest was the perfect thing to use here. Then, as many of you might know, the random forest was constructed using the following steps. First, a bootstrap sample is drawn from the training data. Then, at each node, a random subset of features is selected. So yeah, the features might include the position of the comment, the words in the comment, and a lot of other stuff. Thirdly, the best split of the node is determined. And then on the fourth, we continue repeating the second and third step until a entire tree is generated. Then moving on to the results, I have also got a very similar result, where the augmented data set did not change the F1 scores a lot. And this further proves that we can increase the increase the size of the data set using a large machine model. The original data set here used contained around 11,500 samples, and then another 233 samples were added using ChatGPT. Then, as mentioned, the key findings include that the random forest model was quite effective since it had a F1 score of 0.8. And then the data augmented did not impact the F1 score a lot. So we can continue increasing the size of the dataset to further improve the model. Then for future, a lot of models are required in today's world. So domain specific models can be made in the future. Thank you.
Ashwin, it was a nice presentation. Now it's Om, and then Oritra, and that ends task 1. After which, Aniket, you're for task 2. Aniket, oh, sorry, your name? Shubhankar, you're for task 2. You also get 2 minutes, 3 minutes only, okay? Yeah. And then we start with Azharul, and then Shruti.
Hello and good morning, everyone. I'm Om Joshi, and I'm currently pursuing my bachelor's degree in mathematics and computer science from IIT Goa. Okay, so let's move towards these are the intro, but let's move towards the methodologies that we have used. Okay, so mainly there are like many algorithms that we can use, but mainly we have used these two, like SVM and logistic regression. Okay, so for the SVM part, it is a supervised learning approach for the classification task, and it identifies the optimal hyperplanes to separate classes and excelling in high dimensional and also in the non-linear data. Okay, so and the second thing that it is like a very naive approach that one can use is logistic regression, that we just have to separate into the binary classification, like to 0 or 1, and we can set up a threshold of 0.6 to distinguish between the useful and non-useful comments. Like if it gets the score of greater than 0.6, then we can mark it as useful, or it is non-useful. And these are the equations that we have used, that You can also have a look of that. Okay, and talking about the results we have got is uh, originally we have data set of 11,452 samples, and it achieves the 0.796 F1 score, and the recall value is 0.803. And for the augmented data set that we have tested on it, it is it contains 233 samples, and it achieves the 0.791 of F1 score, and the 0.807 of recall value. And here are the some examples and pictures of the test cases that one can view. Okay. And for the conclusion part, we have achieved impressive results in comment classification, and also we have improved the F1 scores that indicate better identification to useful comments, and recognized our limitations to suggest avenues for the further improvement. And for the future scope, we can talk about that we are incorporating structural features like for the particular part like comment length and position and the keyword ratio that one can use that for the SVM part, that support vector machine. And also we have one takeaway that balancing structural and qualitative features can enhance our classification accuracy. It was all from my side. Thank you. Thank you so much.
Thank you, Om. That was a great presentation. Oritra, are you there?
Yeah, I'm here.
You need to share your screen and also share yourself through the
Yeah,
video or whatever.
Yeah, yeah. Um, I hope I'm visible. Yeah, I'm visible. Share my screen. Yes, is my screen visible? Yeah, it is visible. So, hello everyone. I'm Aditya Mitra from Computer Science and Engineering Department, IIT Kharagpur. So, my work has been similar, exploring usefulness of C commands using Silver Standard models. First, we'll talk about the introduction, then methods, results, and conclusion. So the task at hand was to classify comments as useful or not useful. We trained models using the provided dataset, and then we augment the models, augment the dataset using LLM. We use GPT-4o Mini, basically ChatGPT for this task, and then train the models using the augmented dataset, and then compare the results. We used three methods. All of them were generated by ChatGPT only. We fed the dataset and the task at hand to ChatGPT, and the output is what we used as our models. We got three types of models. One used CodeBird for comment and context. One used BERT for the comment and CodeBird for the context, and the other one used a bidirectional LSTM for the comment as well as the context. From the color coding, you can understand the double BERT performed better than the CodeBird, and the LSTM performed worse. And about the results that we got, we augmented this using GPT-4o Mini. 754 instances were generated, 485 were useful, and 269 were not useful. We augmented them to the dataset, and we labeled them using three types of prompting: IO prompting, chain of thought prompting, and tree of thought prompting. Basically, we give the data and ask it to label. Firstly, we just ask the label for IO prompting. Then we want to know why it labeled such. That's the chain of thought. And then we break the labeling task into subtasks and see where it can go wrong. And that gives us a tree, and we pick the best leaf. That's the tree of thought. Using all of these, we achieve around 79% to 81% accuracy with these models. And after we augmented the dataset, it shows around 1% of increase. The models went to 80 to 82% of accuracy, and the F1 scores followed. So about the results, we observed that all of the models performed better with the augmented data, and there was increase in F1 score, which meant that it did better in the classification of useful comments. And for inference, we saw that the transformer-based models performed better than the LSTM-based one, uh, which kind of gives us the fact that subword level semantics are more important here than character level semantics as we are dealing with comments. And also, double BERT based approach performed better than code BERT, which makes sense because the comment is inherently a natural language feature more than a programming language feature. In conclusion, we see that we have achieved significant separability using silver standard models. And from these models, we can create some gold standard models which may perform even better if we create them carefully. In case of discussion, we can say that LLM generated data is good in when we need more variance in the data, and hence we want to reduce the bias. This will give us an increased F1 score when we have low data to work with in the beginning. However, we know that gold standard data has more reliability and credibility than LLM generated data because, of course, the gold standard data has some backing uh, on how it was generated. So that is it from my side. If you have any questions. Thank you.
Thank you, Aritra. Can we have a clap with him? Yeah, actually, we are running behind schedule by 5 minutes. So questions, whoever gives me offline, I'll float it on to you. So we now move. Thank you for the great presentation. Now we move on to task 2 participant, Shubhankar. Yeah.
Good morning, everyone. So I am Shubhankar from IIT Kharagpur. So today I will be presenting our working note on this title called Coding Smarter, Not Harder, leveraging GPT 3.5 Turbo for automated code solution scoring. So this is a brief introduction. So as we all know, the exponential growth of software systems generates vast amount of data, including source code, technical documentation, and issue tracking records, making efficient information retrieval critical for developers. That is why existing IR tools sometimes fail to meet the complex need of software engineers lacking contextual understanding and the ability to provide the evaluate insights for programming tasks and solutions. So in this work, we have just used GPT 3.5 Turbo in zero-shot mode for scoring the programming solutions based on relevance and effectiveness, enhancing developers' ability to quickly identify optimal solution. So this is the task definition in brief. So it is called as code quality estimation. So the task is given a prompt and the 10 corresponding solutions for each problem. We need to assign a predicted likelihood score to each problem and solution. For example, you can see that there is a code snippet and the comment there is some incomplete solution of that, and there are one solution. So like that, there are for each and every problem there are 10 solutions. Then we have to just pair problem and solution with a likelihood scores. And in the data set there are 164 queries in the test set along with 10 solutions corresponding to every query. And we have just used GPT 3.5 Turbo using zero-shot mode in several temperatures, for example 0.7, 0.8, and 0.9. And we have used the prompt as follows. So given the problem and the solution, generate a likelihood score between 0 and 1, stating how relevant is the solution with respect to the problem. Only state the score. So this is the results of our runs. So this is the submission one for temperature 0.7, submission 2 for 0.8, and submission 3 for for temperature 0.9. And we have got the best result in temperature 0.8, which is local NDCG 0.6615 and global NDCG 0.9109. So this is the conclusion. So our study demonstrates the potential of GPT 3.5 Turbo as a valuable tool in this domain, showcasing how its language processing capabilities can be used to enhance
the relevance and effectiveness of retrieved programming solutions, and also the submission 2, which is the highest results in our for the temperature 0.8, so which is NDCG 0.6615 and and global NDCG 0.9109. So this is it. So this result suggests that leveraging AI driven models like GPT 3.5 Turbo not only improves retrieval accuracy but also supports software engineers in navigating complex development tasks more efficiently. Thank you.
Thank you so much, Shubhankar. It was a nice presentation. So we end our session for IRSC task. So the others, so there are a total of 14 submissions, but others had to be excused due to inter-IIT sports meet. So they have submitted their papers and registrations all done. So you can have a look at their paper once the paper is published in CUR. So now we move on to doctoral consortium session. So this year, the consortium had a total of 8 papers, out of which we actually chose 3 papers. So we wanted to make it more competitive. But then out of 3, I think 1 could not actually travel. So the other 2 students who have actually, they have given very good work. So they are here to present. First is Azharul Haq. And we will be giving you 10 minutes because otherwise I don't think so she'd be okay with 8. Right? So 10 minutes and then after that should be. So we have 2 presenters and we try to close the session by 9:50 so that we have a break of 10 minutes before the keynote starts. So Azhar,
Good morning. Myself, Azharul Haq. I'm from Vishwabhati University. Today, I'm here to present a work on context-sensitive dense structure extraction in hybrid heterogeneous information network. So here's the outline of the today's presentation. First, I'll start with the introduction. Then, what is hybrid heterogeneous network, context path, and context-sensitive dense structure. Then, problem statement, motivation behind it. Then I'll explain the proposed methodology and experimental results, and finally the conclusion. Okay, as we know, in most of the real-world systems, entities are connected in some context. For example, if we consider a bibliographic network, then authors, papers, or conferences can be connected through their research contributions. So this type of systems can be represented as information networks, where basically entities are modeled as nodes and their relations as edges. This type of network can be useful for mining hidden patterns like community formation and some like collaboration patterns, etc. So, however, there are some real-world systems that there can be some relationship between entities which are very complicated. So to model them as information networks can be very complicated. So to model them as information network, we need complicated, powerful tool like hybrid heterogeneous information network, which is basically a interconnected layer where each layer contains basically different types of nodes and different types of edges. So basically in hybrid heterogeneous network, there are 2 types of edges, intralayer edges and interlayer edges. The interlayer edges are basically edges between same type of nodes, and interlayer edges are basically nodes between different types of in layers. So hybrid heterogeneous network has the properties of both CHIN, that is centralized heterogeneous information network, and hierarchical heterogeneous information network. So here we can see a diagram of a hybrid heterogeneous network with 3 layers, basically 3 secondary layers and 1 primary layer. So in order to capture the contextual information presented in the
heterogeneous information network, we use a concept called context path. Now, what is a context path? It is a path between two primary layer nodes, which involves only interlayer edges and non-primary layer edges. For example, if we see the diagram, then suppose author A1 has written a paper called P1, and author A2 has written a paper called P2, and P1 and P2 are on the same topic, then we can say A1 and A2 are contextually related, or there is a context path between them. Now, coming to the context sensitive dense structure, it is basically a induced subgraph of the primary layer, where each node is basically connected to other nodes of the context sensitive dense structure with at least one context path. So in this work, we have addressed the problem of extracting context sensitive dense structures from the primary layer from a given hybrid heterogeneous information network. The motivation behind our objective is that the context sensitive dense structures extracted from hybrid heterogeneous information networks are richer in information, as they provide a broader perspective and a wider range of contextual information compared to the other topologies of heterogeneous information network. Next, the context sensitive dense structures from hybrid heterogeneous information networks can be useful to provide some useful insights to address the important problems like community detection, link prediction, etc. So coming to the proposed methodology, we have basically divided our proposed method into four main steps. So at step one, basically, it finds the temporary context sensitive dense structure in the primary layer with respect to each secondary layer. Then in step two, it finds some temporary context sensitive dense structures in primary layer with respect to each pair of secondary layers. They are basically, there have to be interlayer edges between the secondary layers. Okay. Then in step three, we basically aggregate those edge weights found in the context and temporary context sensitive structures in step one and step two. And in the final step, we basically remove those edges from the temporary context structure that has weight less than a predefined threshold value to construct the final context sensitive dense structure. So we have conducted some experiments on two synthetic networks and compared our proposed method with the method called K-context technique for centralized heterogeneous information network. And here we can see the experimental results. To evaluate the proposed method, we have used a metric called OACC, which basically finds the denseness of the overall denseness of the extracted context sensitive dense structures. So from the experimental results, we have observed that as the degree of context increases, the proposed method detects better quality context sensitive dense structures compared to the K-context centralized heterogeneous information network method. So our future research would be directed towards a detailed investigation into the potential of these context sensitive dense structures for the downstream applications such as community detection, link prediction. So that's all. Thank you.
Any question?
Yeah. Yes, sir. Yes, sir. It can be it is basically a multi-layer network. We are basically decomposing the network as multi-layer, and depending on the criticality and based on some applications, we are basically deciding which layer should be the primary layer and the other secondary layer based on some critical. Yes. We have used the K-context CHIN method. Basically, this architecture for CHIN and architecture for our proposed method is almost similar. So that's why we have selected this. Thank you.
Yeah. Oh, okay. Thank you so much.
Thank you.
Okay, the next presenter should be.
Good morning, everyone. I'm Surbhi from IIT Patna. So my topic is detecting deepfakes, so exploring the frontiers of deepfake generation and detection. So deepfake technology are very common nowadays. So we can see like from politicians, celebrity, journalists, everyone are affected by deepfake. So these are the some news articles. These are the few examples of deepfakes, deepfake video, deepfake image. So my contribution is that we found a research gap that mostly the fake face data set are available, but it is in foreign face, mostly of foreign faces, not in Indian context. So we try to create a data set named Indian fake face data set. And for that, we have developed a web application to generate high quality Indian fake faces. And we have also developed an Android application and a web application for the detection task. So this is the web app generator. So here we have collected Indian facial images from Google API, and just we align it to ensure the quality. And then we trained the StyleGAN V2 model to generate the high quality faces. And then we use some style mixing features by combining features from multiple latent vectors. And then we use this GFP GAN model, that is a generative facial trial GAN model. It is a super resolution model, so it restores faces and improve the finer details from the faces. And so at the end, we are able to generate the high quality Indian fake faces. Basically, it is an interactive graphical user interface app for fake face generation. So I have a demo. So I'm just doing a demo. So this is the generator. So here, like it is an iterative process. It generates 16 random vectors and corresponding to 16 facial images. So it uses have the option to select this feature, like coarse features, the shape of the face or the structure of the face. Then medium level features like the hair or the eyes, and then the fine features like the skin tone, texture. So at the end, like we are able to generate the high quality fake face. So from the resolution of image 256 to 256, we are able to generate the high quality face of resolution 512 into 512. So these are the few examples of high quality Indian fake faces. Then we have developed a Android app for the detection task. So here the users have the option to scan an image and detect it, or it is also integrated with the WhatsApp. So user can upload the entire folder and generate a report about it, that how many images are fake or real, and yeah, scanning a folder also. We have also developed a web application for this. So where we try to cover all manipulation techniques, from traditional approaches to the new generation model, and we covered the facial image and facial image and video also, and it is trained on different kinds of data set. And it is also integrated with Twitter, where we can see some fake faces post, and just we get a statistics of it. So basically, this is the Android app and the web application. Its use cases is that this Android app we can use on mobile devices. It generates a report of number of fake and real images are stored in a folder, and it can also be integrated with other apps for detection for detecting fake. And this web application, we can deploy it on any device or server and detect images or videos stored in a device. And this web app generator, we can use for generating high quality fake faces. And yeah, embed the web app into, we can embed this web application into other websites and can check and detect the fake. Yeah, and we can also integrate with other social media platforms like Reddit, Instagram, and check this deepfake. Yeah, that's all from my side. Thank you. Any question?
Yeah, and congratulations. I mean, it's a nice work. So my question is, I mean, how Indian faces are different from, say, American faces or European faces? I mean, what are the, distinguishable features for Indian people?
Skin tone are very different. White faces and Indian faces are very different from the like foreign faces we can see.
I mean, that's my question. I mean, I cannot distinguish, Indian from a Bangladeshi or a Sri Lankan. Uh, even though, there may be a regional, a very subtle feature, but it's very difficult to distinguish, maybe among the South Asian people. Okay.
Right, so,
So,
actually, for Indian cases, I was in an MHA project. So there were mostly the cases are from like the crimes related thing. So they want a very specific data set for the Indian faces, in Indian context. So for those cases, we created this data set. So they are very specific to Indian cases. If we train a model on mostly the face forensic cluster data set, and the other data sets are available, but that model doesn't work for Indian cases. So for real-time cases, that's why we created this data set in Indian context, and we train model on it, and we run it for the Indian examples. So that was working fine with this.
I have one question. Like,
Yeah.
there is a technique called face swap technique to create deepfake images. In
Yes.
that, we literally just swap the faces.
Swap it.
So in that case, will your model be able to detect that?
Yeah, sure. It is one kind of example where we are using StyleGAN V2 to completely generate new faces. But in our complete data set, we use the different techniques also. Like your example, for the face swap, we use the Face app. This is one application available. It is freely available. You can use on your mobile phone and just swap and see. So just to make the data set diverse, we use the different techniques also for this face swapping also, and then we train the model on that. So basically, this generation model will not work. So it is completely generating new face. But detection model, what we have trained on different kinds of manipulation techniques and this generation type. So there, our model will work for detection, that detection model. For detection module, it can detect of any resolution from 256 to 512 because I. Yeah, it is able to detect because we have a data set that contains a very low quality faces also. So if model is trained on that, it will be able to detect the low quality fake faces. Yes, yes, yes. Yeah, there are bias, but there are many data set available that contains the low quality spaces. They have the data set have the this categorization, low quality and high quality. So if you are training on that data set, then it is able to detect both from low quality to high quality spaces.
I suppose the square looks great.
Recording.
मेरे को बोलना पड़ेगा जिसको क्या है ब्रेक कब हो नहीं ओके 10 बजे ब्रेक कब हो हाँ 10 बजे से पहले 9:50
Okay, is it okay I start my talk?
Yeah, sure.
Okay, good morning, everyone. This is Yichun from Tsinghua University in Beijing. Sorry that I cannot attend the FAIR Forum in person due to visa issues. I started the visa application process as soon as I received the invitation in August, but still cannot get the visa. I sincerely hope I can attend the FAIR events in physically when the application process becomes more friendly. Today, I would like to talk about the evaluation of large language models, especially in legal domain. Since 2019, we have been trying to adopt AI techniques to help judges and also lawyers in the Chinese legal system. And with the experience of large language models, they have benefited a lot from this progress. However, we all know that legal scenarios are very complex and many times very sensitive. So therefore, evaluation always sits in the core of this kind of vertical application and corresponding researches. Today, I would like first to discuss about the application of large language models in legal domain, and then the core topic is how to evaluate this kind of LLMs. And finally, I will give some discussions about future directions. We all know that information overflow happens everywhere in our modern society. And with the digitalization of this kind of judicial process, more and more data actually are stored in this kind of electronic form. So many legal workers, including both lawyers and judges, they are struggling in finding the correct information in these kind of scenarios. For example, we have been working with many courts around China, including Beijing, Shandong, Shanghai, Chengdu, a lot of this kind of courts. Many judges, in fact, they have to deal with over 300 cases per year. It means that for each day, they have to go through the whole process of preparing documents, the court procedures, perform a lot of similar case retrieval, something like that. We believe that this kind of advanced AI techniques can help them, and they actually strongly needed us to help them to better get this kind of all these procedures automatically. That's what we have been doing. So with the development of generally with generative AI, especially with LLMs, and we found that much efforts can be reduced with the help of AI tools to help this kind of legal workers. For example, before the court procedure, LLMs can help with early risk preventions, and they can also help the both sides in the court to access legal information, and they can even resolve some simple disputes before they actually come to the court. So they can prevent small disputes growing into large ones. That's very important. During the litigation process, it helps judges to generate legal documents automatically, and it can actually significantly reduce the time and efforts in preparing these documents. It can also recommend related evidence or even similar cases to the judges when appropriately. It can also increase both quality and efficiency of this kind of process. After the litigation, it helps with valid case execution and tracking. It makes sure that the law judgment can be executed correctly, and also generate judicial data and also analysis reports to support the governance of certain cities or even provinces. So we believe that when adopted properly, large language models can contribute to a human-centric judicial process. It can improve judicial efficiency, enhance judicial fairness, and expand access to justice and support this kind of judicial innovations. So that's why we use AI for this kind of process. But after this process, our core is that how to evaluate this kind of large language models, because as an information processing tool, it's very important to evaluate its performance, both for the development and also for the application side. So we propose how to evaluate this kind of things. Actually, before the appearance of LLMs, there were already a large number of legal AI applications, and their corresponding evaluation methodologies has also been proposed. However, this kind of traditional legal AI evaluation methods focus on several independent evaluation tasks. There are a lot of tasks, and for each task, they design a specially specific metric or even some metrics, and they have some different rankings. But legal large language models, they are different because it can particularly it can deal with a lot of different kind of tasks. They are usually designed to complete various legal tasks with a single model. So the evaluation of this kind of legal LLMs should cover multiple aspects in this kind of legal ability and to solve different legal problems, and should be applied in different legal scenarios instead of just one. So we have to develop a full system that can evaluate this kind of things. In light of this kind of existing limitations, we propose a comprehensive legal benchmark for evaluating LLMs. The benchmark is inspired by Bloom's taxonomy. Bloom's taxonomy is very famous in educational science, and it has been referred to as the taxonomy of educational objectives. We believe that this kind of training process of large language models can be quite similar with the learning process of human beings, because human beings are also trained, especially for legal domain. They go to the undergraduate studies. After that, they got the degrees in law, and before they get the lawyers positions, they will go to some bar exams, something like that. Very similar with human beings. We believe that this kind of model training process is very similar with human beings, so we can use the educational science taxonomy as inspiration for our evaluation framework. We believe that this kind of evaluation process can be quite similar, so we follow this taxonomy to design our legal LLM evaluation taxonomy. We call it LexEval. After analyzing all different kinds of legal tasks and their intrinsic connections, we propose a legal cognitive ability taxonomy. We call it LexEval taxonomy. It includes actually 6 different aspects. The first one is memorization. You have to remember something. Before that is understanding, and above that is logical inference, and then discrimination, and then generation, and finally some ethical issues. Based on these different kinds of ability aspects, we design legal evaluation tasks separately and construct the legal large language model evaluation taxonomy. The taxonomy then is adopted to evaluate the large language models. In detail, we will introduce each level, which kind of tasks are in each level, and for each level, what kind of ability they focus on. This kind of taxonomy adopts standard evaluation methods and metrics in each level, and we believe that it sets a solid ground for the future expansion and the integration of different kinds of legal tasks. It means that although we already define a lot of tasks for each level, if we have new tasks, it can also be incorporated in this kind of taxonomies. At the memorization level, large language models are tasked with memorizing and recalling all different kinds of legal information, including for example, they have to remember fundamental legal concepts and also the articles in the whole law system. It also, for example, for case law, it also have to remember a lot of different similar cases, and also the basic legal principles and specialized legal terminology among all the essential contents. So we also design a lot of tasks, for example, how to remember these legal concepts, how to recite it, the articles, and how to remember the whole evolution process of laws, because for different regulations, we have a long history of evolution. At first, it is legal, then it's illegal, or vice versa, something like that. You have to remember which time is legal or which time is not. So you have to remember a lot of things. This kind of task is a memorization task. Above that, that's understanding task. For the understanding level, the models must demonstrate an aptitude for comprehending the meaning and implications of legal information. They should possess the ability to interpret legal documents. They should be able to extract legal elements. they should identify the key legal elements in all the different kinds of case descriptions. It should analyze the documents and understand the structures. And they also should understand some basic logical relationships between different paragraphs. For example, for each document, it's actually very, very structured. For each different parts, what's the relationships between different parts? They have to remember that, and not remember. They should understand that. So the basic logic meanings should also be understood. Above that is logic inference. Different with understanding, logic inference focus on more fine-grained logic values. It involves the capacity for legal reasoning and even deductive logic. It means that with this kind of evidence and with these law articles, what's the problems with this defendant and what kind of punishment we should give them, these kind of things. Guideline models should also be capable of deducing conclusions based on provided legal facts and rules, and it also should be able to identify and apply legal patterns and principles effectively. It should perform multi-hop reasoning, such as many current guideline models already do. And it also should do some legal computations because the calculation of, for example, fines and the interest rates is something is also very important. We believe that the model should be able to do some simple methods to calculate these kind of things. Also, sentence prediction, we believe that is a kind of logic inference because based on the evidence and based on the law articles, it should predict the sentence, these kind of things. Above that is discrimination. Discrimination means that the models should be able to analyze and evaluate the significance of legal information according to specific criteria and support decision makings. I think we should point out that we do not require the models to make all the decisions. It should just make suggestions to the judges or lawyers. It means that it should be there to help, not replace the law workers. It should support the decision makings instead of making decisions by themselves. For this kind of abilities, we focus on, for example, relevant case retrieval. It's very important for us. We should find similar cases based on the facts descriptions. And also it should identify some fake information. For example, if there are some incorrect legal rule reference, and there are, for example, something like some evidence looks very not true, you should identify this. And also, it should evaluate the likelihood of whether this sentence may be overruled by a Supreme Court. It should do this kind of discriminations, and that's very important for the judges to improve its performance. Then above that is generation. Generation is very important because language models are supposed to generate new text. For this kind of things, language models are expected to produce professional legal documents and also augmentative tests within specific legal contexts. This includes, for example, drafting some legal writings, drafting some contracts, or even providing legal opinions based on the legal facts. These models should also generate very accurate, legally sound, and well-structured text based on given conditions and requirements. If they can do that, it should greatly reduce the judges' and lawyers' efforts and make the whole legal system more efficient. So generation is also very important. Above that is ethical issues. Ethical issues is very, very important because we are humans, and humans should follow the social values. It requires a model to make judgments about ethical issues in the legal domain. Models should identify and analyze legal ethical issues, legal ethical problems, and even make some decision support for these kind of things. It should weigh the advantages and the disadvantages, and it must consider some ethical principles of law, professional ethics, and social values in their decision supporting process. It is very important because we know that when we test several existing large language models, we found that with all the very, very similar case facts, but if the problem happens to a man, or it happens to a woman, or it happens to an old man, it happens to a young man, the models may make different decision supports. That's very bad, because we believe that it should ignore this kind of things and just make the decisions based on the facts. Sometimes it should refer to these demographics, but many times it shouldn't. So ethics is also very important, and we should design different kind of tasks to analyze and to help the models to evolve based on this kind of tasks. So altogether, we know that there are 6 levels, and the 6 levels of abilities are not disconnected. We can see that the tasks from some lower level abilities often support tasks from higher level ones. And all the tasks should also follow the ethical alignment requirements. So it's connected and it's a whole. It can be performed as a whole. So with this kind of taxonomy, we can test whether this large language model can be adopted in legal domain or not. We also compare different kind of legal large language model benchmarks. There already exist some benchmarks. We found that, for example, there are LawBench and also CEVO Law or something. We found that, for example, the 6 different levels, we cover all of them, and most of these existing benchmarks they only cover parts of these different kind of abilities. And we also own the most tasks and the largest number of test cases. So we believe that this benchmark can really help us to improve the designing of legal large language models. If we just propose these tasks, it's not enough. As an evaluation benchmark, for example, at FAIR, we also focus a lot on how to annotate the data, how to design the evaluation metrics. So we also discuss a bit about the evaluation methodologies. It means that we should provide a general guideline for all the tasks in this kind of taxonomy. We believe that there are several things we should care about. The first thing we should consider is data collection. It means that we should how to collect this kind of data in the constructing of these benchmarks is very important because sometimes legal data is very sensitive. The first thing we should consider about is diversity. There are various types of legal contests. It is very easy for us to cover some popular ones and ignore the not so popular ones. It's not a good thing because for each person, although it may be involved with some cases that are not so popular, they also require justice. So it is important for the models to know everything. Not just the popular cases, but also the unpopular ones. It should cover different kinds of case types and also, for example, the different kind of case clause, contract clause to reflect the diverse legal scenarios and needs in the whole real world. It also should be balanced. It means that it has roughly the balanced number of cases from different kind of causes. And it also should be real. We should collect data from real world instead of get some unreal ones, develop our new ones. That's not good. Also, the scalability is also very important. We should offer scalability and adaptability. It means that it should be easy to accommodate new legal tasks. There are always some new tasks because after the lawyers or judges are familiar with the current model, it may raise several new requirements, and we should design new tasks to help them to develop these kind of things. Quality is also very important. We should eliminate bias, and especially we should remove all the misinformation or noise. And finally, security or privacy is also very important. We should ensure the confidentiality and the safety of the data is very important for both for criminal law and civil law. Both are very important. For this kind of things, it means that we should take care of this kind of data collection. And after that, we should cover different kind of task types. And for different task types, we should use different evaluation methodology. We hope that all these kind of tasks can be annotated fully automatically, but sometimes not possible. So we should make the whole process as automatic as possible to reduce our efforts and also to make sure the whole process is fair. There are different kind of query types. We know that, for example, there are objective ones and also subjective ones. And for objective ones, for example, legal computation is a kind of objective, and for subjective ones, such as case file generation, is highly subjective. So for this, all different kind of query types, there are also different kind of answer formats. For example, there are multi-choice selections. If we would like the model to go through some, for example, bar exams, there are always several multi-choice selection questions. It's very simple because we can just use accuracy, whether the model selects the correct answer or not. But there are also some fill-in answers, means fill in the blanks and, for example, several keywords of several phrases. For this kind of things, we should use the large models to compare the fill-in answer with the reference answer, whether it is correct or not. And also there are several free-form answers. That's very, for many different kind of bar exams, both in China and in the US and in other countries. There are several free-form answering questions. And this kind of things, we should design several large model peer review process. I think there are actually a lot of work recently about large language model as judges. So we should use this kind of techniques to judge, to evaluate the quality of this kind of answers. So for annotation process, we have different menu. For example, we have a manual annotation. We believe that for some particular ones, we should provide several seed answers annotated by human. Not so many, but we should have these ones. Especially for multi-choice selections, manual labels and exact match is required, and it's really simple. But for fill-in answers with reference code standards, we can use large models to make judgments and give, for example, rankings or at least several grades for these answers. But for free-form answers, we can use different kinds of general or vertical large models to give a ranking based on the peer review mechanisms. Things are also very different when there exist reference answers or not. But for this kind of free-form answers, there are usually several references. So we can also compare this reference, whether it is proper or not. As we said, for multiple choice selection problems, it's very simple. The variation is very simple. We can just use accuracy to measure the performance. There are several instructions and propose a query, and the correct answer is C, so you can choose whether it's correct or not. For free-form answering with references, we can use the text similarity calculation process, and also we can use the large language model as a get judge. We can use ROG or something like that, and we can also ask large language models to do the label work. It should compare the answer with the reference ones. And for free-form answers without references, we can also rely on LLMs to act as both reviewers and perform a peer review. Discussions can also be involved among these kind of large language models so that it can make more reasonable prediction and more explainable prediction. For this kind of things, we have published several papers and give you there are a lot of existing works, so I just give you a brief idea. At first, we should select a number of strong LLMs as reviewers, and then the selection can be performed based on a small set of annotated data, or what we call this qualification exam. We use this qualification exam to make sure that this LLM is qualified to enter as a reviewer. Then the reviewers review all the candidate results, and the result aggregation is performed by a chair model. It means that we have a SPC or something, or meta reviewer to make the final decision based on the peer review results. With this legal ability taxonomy and evaluation methodology, we can actually design different evaluation benchmarks within this kind of taxonomy. And with this methodology, we actually organize a benchmark workshop named Challenge of AI in Law, or it can also be called CAL. CAL is initiated by Tsinghua University from the year 2018. Of course, before the large language model appears, we mainly focus on all different kind of AI tasks. But after 2022, we mainly focused on the evaluation of large language models in the legal domain. For example, in 2023, we have 7 different tasks. And we especially design a task for evaluating the performance of large language models. This year, 2024, we have 8 tasks. Both of these tasks are focused on legal practice. Here are all the tasks we already organized in the past few years. We can see that there are about 20 different tasks or even more. And not all the tasks are at first designed for large language models, but currently we can see that all these kind of tasks can be used to evaluate different abilities of large language models. So it is a nice thing because all the previous models, although they are not large models, but they are sometimes some programs and some APIs. We stored all these kind of applications in our servers, and we can compare language models with these performances. As in the other benchmark workshops, such as FAIR, such as TRAC or NTCR, we started by calling for proposals, and then the task organizers are supposed to prepare the data, but we can also support some annotation teams to help them. After we featured a closed testing phase. It means that not just we do not send out all the topics at the first time, all at the first time. We reserved some particular topics to perform a closed testing. And after the preliminary round, for example, we can choose the top 20 or 30 groups, and then they enter the closed testing. And in the closed testing, each team is required to propose some APIs to us. And we use a closed test topic to test the performance. Usually, in the closed test, the number of topics are much larger than the preliminary phase, and sometimes the tasks are slightly different. The topics covers much broader types of cases, for example, to make sure that the models are robust enough. And in the CAL conference, we also provide a small amount of awarding money to encourage participations, which are sponsored by several legal technical firms. In fact, many firms work with us. to develop this kind of tasks. As I said, in 2024, we have altogether 8 tasks. For example, including judgment fact generation, reasoning generation, legal consultation generation, element and issue identification. Here we also say qualification examination. The qualification examination is organized by the legal department of China and is very similar with the bar exams. And there are altogether 8 tasks. We can see that over 650 participation teams, not just from China, also from US and European countries. As we said, we use some small avoiding money, but it appears that many students, especially graduate students, they are very encouraged by this kind of things and they participate a lot. And for each task, we have 80, for example, around 100 different teams, and the qualification examination. This kind of free-form answering is very difficult, so not so many participate in this kind of tasks. In January, we will have our CIL conference this year, and all the top-ranking teams will come and to help with us with how to improve the current techniques, both in evaluation and in the legal applications. One thing I should mention that is that most of these task organizers are joint teams. They are composed of both legal workers and also computer scientists, professors. The Supreme Court of China also participated in the task designing and provide a lot of different kind of suggestions. For example, the appeal case prediction is what they suggest because they want to reduce the number of appeal cases. So they propose this kind of task to us. Finally, I should give some conclusions. The first is that we believe that large models can improve the efficiency of legal professionals, and since we are, I think, similar with China, India also have lots of different kind of cases in the legal system, and the legal system struggled to deal with all these kind of cases. So AI techniques can help them. And if we want to choose some qualified AI models to help these legal professionals, we should use our evaluation technology to choose this kind of qualified AI models. That's what we should do because mostly we are university professors and we are not companies. So the legal system, for example, the Supreme Court in China, they trusted us. So we design this kind of evaluation benchmarks and to evaluate the different performance. After a certain, for example, criteria, then it can actually go into the legal system to help the legal workers. In this talk, I just give you a precursor legal large model ability taxonomy, and we also propose several evaluation methods for different kind of legal tasks. That's what we do currently. And CIL 2025 is also calling for proposals. If you are interested, you can contact Qingyao or Yue from my group, and we can all together to design some new tasks. Not just in China, but also all over the world to help our legal professionals. That's all for my talk. I wonder whether you have some questions.
Hello. Yeah.
Hello.
Yeah. Hi, Professor. I'm Surupendu.
Hi.
Yeah. So
Hi.
that's a nice talk. So there's only one question from my side, like how difficult is it to maintain the fairness in these models? Like suppose the LLM is a judge. So is there a possibility like it's biased towards particular minorities or towards particular genders and it gives biased decisions?
Yes. As I said, that's very important. For example, before our for example, most of these existing benchmarks, they do not, let me see. Okay, most of these existing benchmarks, they do not care about the ethical issues. But that's what we are talking about. One of my PhD students developed several ethical tasks. For example, we can replace several case descriptions with some counterfactual descriptions. For example, in this case description, actually the criminal is a male, but we replace it with a female, and we would like to see how the final legal judgment changes with this kind of our modification in the case descriptions. So we design a lot of these kind of tasks to test the ethical issues of different legal language models. And we believe that this kind of task design can help us to make sure that these models care about ethical issues. That's what we are doing.
Like just a follow-up question, like since there is a human in the loop already, like since the data is already generated by humans, there is a possibility like the same case will have different judgments in one particular year, and then followed by some more years, the case gets revised and a new judgment is passed. So like how can we make the LLM understand that this is some change in judgment in the same case actually?
Yes. Actually, there are several different ways to make sure that the models can actually work with these judges. For example, at first we already trained the models. We are actually doing this. We trained the models with several, for example, legal agents. These agents can use different tools to solve different kind of problems. And with this, we actually develop different simulation cases. It means that although we cannot test with different judges, but we can test it with different simulated judges to make sure that the models actually can work with different kind of these different styles judges. Some judges are more strict than the others, or we have different settings to make sure that the models can provide different suggestions to these different kind of judges. Because also very similar with India, China is very large. There are different provinces and different styles of judges. What we want to make sure is that if a similar case happens in this province, it shouldn't be, the final judgment shouldn't be so too different from in another province. If it actually happens that the judges make a very different decision, at least the models should provide several suggestions. And in the legal system, there are several, for example, superior judges, more senior judges, and usually this kind of judges probably they will correct the judgment of this not so reasonable judgments. I don't know whether it solved their problem or not.
Okay, so I will open the floor for the audience. So any questions from the audience?
Hi. Am I audible?
Hello?
Hello. Yeah. Am I audible?
Hi.
Hi. Hey. Okay. This is Prashanjit.
I beg your pardon?
This is Prashanjit.
Okay. Please.
So I just quick loud thinking. It came to my mind while listening to you.
Yes.
The AIL challenges of AI for law. This
Yeah.
you said. So I mean, FIRE is something a similar forum. So is there any possibility that CAIL and FIRE can collaborate for a track where we can mostly pose it for the Indian participants?
Yes, of course. I think we can cooperate. Actually, earlier this week, I have been discussing with Noriko in NTCIR, and the next year probably we should not in the name of CAL, but probably we have some joint tasks. We can propose have joint tasks. The task can also be proposed either by FAIR people or by CAL people, but it should focus on legal issues, and then we can call for participants both through the CAL channel and also FAIR channel, and probably also NTCR channel. Then altogether we have some we have more participants, and it can be a bridge between different communities. Yes.
So I mean, just in case, so then what should be the actionable points from now? Because we have one more year
Yes.
before next FIRE. This time NTCR will happen, I think, in the June cycle.
18 months. 18 months actually. Yeah.
So 2026 June or July or sometime NTCR will be.
You know, I'm also the general chair for NTCR this year. Previously, we have been discussing about moving NTCR from 18-month cycle to 12-month cycle. Also, CL is also 1 year cycle. So I don't think, I think from here to about 2 or 3 years later, we will probably all become the 1 year cycle. So there should be no problem.
Yeah, I mean, in that case, that would be, I mean, then we can place the dates so that people can travel to Tokyo and then from Tokyo to India or the other way around.
Yes, that will be great. There's no need for us to travel out. We can organize different semi-workshops in different venues.
Right.
Yeah, probably I think a similar case retrieval, this kind of things are very, it's very simple. It's also follows the Cranfield methodology, and it can be shared by different benchmark workshops.
Right.
Thank you.
So maybe we can just, I mean, offline, we will start this conversation.
Yes, they should do that. They should do that.
I just pass my regards to Noriko and Tetsuya.
Thank you.
Okay. Thank you, Professor, for joining the conference.
Thank you. The honor is mine.
Okay, so we'll move ahead with our program.
Okay, I will stop sharing.
Yeah, so next we begin with the track presentations for sarcasm identification of Dravidian languages for Tamil and Malayalam.
Good morning. So this track is on the sarcasm identification of Dravidian languages in Tamil and Malayalam for Dravidian code mix data. So we have around 10 presentations in this track. A few of them are online and a few of them are offline. So I would like to call upon the first presentation. YouTube Comments Decoder leveraging LLMs for low resource language classification by Aniket Deroy and Subankar Meiti. I request all the participating teams to upload the presentations so that you can use it. Thank you. Each participating team can take just 5 minutes. So since we have 10 presentations, please stick on to the time. Thank you.
Welcome everyone. Welcome everyone. Today I will present YouTube comments decoded leveraging LLMs for low resource language classification by Aniket and Suvankar. So the task here was we were given Tamil English comments and Malayalam English YouTube comments, and the task was to determine whether it was sarcastic or non-sarcastic. And each comment or post was annotated at the message level for sentiment polarity with particular attention to the challenges posed by class imbalance reflecting real world scenarios. And we experimented with LLMs like GPT 3.5 Turbo via prompting to classify comments into sarcastic or non-sarcastic categories. So this was the dataset setting. So we primarily use the test set for our predictions directly via prompting. So we mentioned the statistics corresponding to the test set. The Tamil testing dataset was 6338 comments. The Malayalam testing dataset was 2826 comments. The task definition, it's to accurately classify YouTube comments that are written in Tamil English and Malayalam English code mix into two distinct categories, sarcastic and non-sarcastic, using an AI model. Why prompting? So these are basically the reasons why you used a prompting approach. First is the natural language understanding capabilities of GPT 3.5, leveraging of the large pre-trained knowledge of GPT 3.5, reduce need for fine-tuning, adaptability to multilingual and code mix text, improve interpretability, and reduce need for task-specific data. So this was our methodology. We used the GPT 3.5 Turbo model via prompting to solve the classification task. We used the GPT 3.5 Turbo model in a zero-shot mode. And the prompt that we used was, please check whether the text was the YouTube comment inside the braces text. We placed a YouTube comment and we asked it to check whether it is sarcastic or non-sarcastic. And we asked the model to check only state sarcastic or non-sarcastic. And we used the same prompt for both Tamil language and Malayalam language and ran the model at 3 different temperature values, 0.7, 0.8, and 0.9. So our team ranked in the 9th position with a score of 0.61 for the Tamil task, and for Malayalam task, it ranked in the 13th position with a score of 0.50. So these are the detailed results. So we see that for the non-sarcastic class, the results are a bit better, but for the sarcastic class, the results are poorer. So basically our intuition behind this was that the amount of pre-training that has gone into GPT 3.5 Turbo, the amount of non-sarcastic information in the pre-trained knowledge of GPT 3.5 Turbo is higher than the amount of sarcastic information in the pre-trained knowledge of GPT 3.5 Turbo. So it is able to classify non-sarcastic comments better. So that is the reason for the difference between higher accuracy for non-sarcastic class and lower accuracy for sarcastic class. And this same observation is for Tamil language. And both for Malayalam language is even poorer. So for non-sarcastic class, it's 0.82, but for sarcastic class, it's 0.22. So these are our conclusions. It will be crucial to explore ways to enhance the performance of both systems, particularly by focusing on the nuances of sarcasm detection, by improving the training data and leveraging more advanced modeling techniques. And we need to do further data analysis to see where we can improve. And the future work could focus on fine-tuning the GPT model so that the results could be better. Thank you.
I have two questions. One is, did you try doing any augmentation to improve the sarcasm class?
No, in this work we did not.
Maybe that could have improved your results. That is one thing. And second thing is, I mean, you have said, how did you do the prompting to handle the multilingual data that is available?
We use
GPT models are basically trained for English language, am I right? But whatever is the data set that we have, it is actually having both English and Tamil multilingual data is there. How did you do or manage the prompting?
So we directly use the we use simple prompts.
please check whether the comment text is sarcastic or non-sarcastic, only state sarcastic or non-sarcastic. So that may be the reason why the results are not that good. But future work, we can try back translation, where we
Yeah.
convert those Tamil English and Malayalam English back to pure English, and then maybe results could improve.
So
Back
the
translation
prompting is not saying about any language information or anything. So
Yeah.
that is also one of the reasons that you can focus on.
Yes.
Thank you. Thank you for the good presentation.
Thank you, madam.
I'd like to call upon the second team. Sarcasm detection and identification of Dravidian languages using machine learning approach by Ms. B. Bharati.
Good morning to all. Our paper is sarcasm reduction using machine learning approach. And the authors are Mugambigai, Kamesh, Parvata Priya, and myself from SSN College of Engineering. Our team name is SSN Language. And here the problem statement is we have to detect the sarcasm, whether it is the given text is sarcastic or non-sarcastic, and the text may be of code mixed. That is a mixed scripts are there, and it is annotated. And here through this task we have obtained the training data as well as the development data, and we have used some basic feature extraction method such as term frequency and inverse document frequency, and we have tried few machine learning approaches. And before that, before extracting the features, we have did some pre-processing, and we have normalized the text, and we have removed some noises present in that, and we have removed some punctuations as well. And then from the pre-processed text, in order to improve, in order to make the data set balanced one, and we have used SMART and for augmentation. And then from the augmented data, we have trained using some machine learning approaches. And these are all the pre-processing steps we have done. Text normalization. So informal language like slang abbreviations, non-standard spellings were corrected and which were standardized. And we have done tokenization. We have splitted the sentences into words. And there are some mixed languages also. And we have done some script conversion also. So the Tamil and Malayalam were converted into Roman script for consistency. And we have done class imbalancing by using SMART. And the next step is feature extraction. And we have done TF-IDF vectorization. And after the vectors are obtained, then we have tried different models like logistic regression, random forest support vector mission, and multinomial naive-Bayes approaches. And in that is, we have tried different parameters. We have fine-tuned the machine learning models with the different parameters. And for support vector mission, for example, we have applied linear kernels and so on. And we have tried it with two different data sets, Tamil English data set and the Malayalam English data set. And for both the data set, the logistic regression is giving a better score, about 0.87 for Tamil English, and Malayalam English it is 0.91. And the challenges we have faced is the class imbalance because sarcastic text are lesser than the non-sarcastic one. And even though we have used SMART, and sometimes the SMART may not give the sarcastic sentences, the actual meaning of the sarcastic may not be included. So in that case, there may be a performance reduction and the code mixing. So here, since we have used the code mixed language, we have just converted that into a normal Roman script, and in order to maintain the consistency. But we have to, in further research, we have to try with for code mixed data. We have to try for different approaches to handle the code mixed data. And here it is, the annotation is a subjective annotation. And here the differences in sarcasm interpretation among the native speakers lead to inconsistent labeling. So we have analyzed a few sentences which may not be sarcastic, but which is labeled as sarcastic one. And this is subjective annotation, and that also leads to some reduction in that. So the overall conclusion is we have tried, we have extracted, we have done some pre-processing and tried TF-IDF feature extraction and tried with the different machine learning models. And the challenges I have already mentioned, and we have to do some further research on how to handle the imbalanced data and code mixing and that things. And here these are all, there may be future work that we could do. So deep learning models, suppose if we want to do the machine deep learning approaches, but the data set size is a little bit less, and we have to have a large data set to use the machine deep learning approaches. And once the model has been trained, and which could be tested with the real-time applications, and we thought of making a generalized approach for detecting sarcasm and so on. And we could have tried with the different features, like instead of lexical features alone, we could have some contextual features could be extracted in order to identify the sarcasm in a better way. But here in the sarcasm detection, we need to not only the current context, we may need a previous context as well as the next context. So if you have that particular data, then the sarcasm reduction performance may be better. So this is all about our work. Thank you.
Yeah, thank you. You said, I mean, what is the maximum score that you got in both subtasks?
It is for logistic regression, it is 0.87 FN score. And then for both the models, the logistic regression is giving better performance. That.
Giving 0.87 and
0.91. We ranked, I think it is fifth rank.
Fifth rank. One thing is good to see is that we are using simple features that are being extracted like TF-IDF, which is not going to capture much of the context, but still it is giving very good results. So if we capture, as you said, as one of your future work, if you try to capture the contextual informations and try to do some kind of contextual embeddings, that may give little more results. And one more question is, you said something about translation that you did for what purpose?
In order to make it as a single unique script, because something in a native script and something in English.
Oh,
so
you
we have
converted everything into English, or you converted everything to the...
transliteration. We have done transliteration and everything in a Roman script, and then we have to use that.
Oh, you have converted into English.
Not
Tamil language or
transliterated. Because
transliterated
something
one
in
you
the own language is also there, so that we have converted.
converted to English. Yeah, okay. Thank you. The third presentation is on unmasking sarcasm, exploring MBERT plus CNN and LSTM models for sarcasm identification in code mix Tamil Malayalam text by Kavya G.
Hello.
Good morning to all. My name is Kavya Ji and I am going to present our paper titled Unmasking Sarcasm, Exploring Embed plus CNN and LSTM Model for Sarcasm Identification in Tamil and Malayalam Text. So the authors of this paper are Sunit D, Kavya Ji and HL Shashireka. We are from the same university, that is Mangalore University. So the task is a binary classification. So the given text we will have to classify into sarcastic or non-sarcastic contents. So in this direction, what we have done is we have proposed two of the models, that is Embed plus CNN and LSTM models. So here the sample text we can see in this table. So Tamil English as well as the Malayalam English. The statistics of the table will be seen in the table 2. So when we see the statistics of this table, so the sarcastic contents are very less compared to the non-sarcastic contents. So what we have done is to deal with the data imbalance, we have done the text augmentation. So for the text augmentation, we have used NLP augmentation library. So with that, we have used the contextual word embedding. So the BERT, which supports for Tamil as well as Malayalam. So we have used that to increase the samples of the sarcastic to match with the non-sarcastic contents. So we have matched the non-sarcastic content size. That is the same size will be trained for the model for the classification. So the first step, what we have done is a text augmentation. Then the augment text is undergone to the pre-processing. So two of the models we have proposed, that is LSTM and Embed plus CNN. For the LSTM, we have done the step, that is augmented text will be pre-processed, and the pre-processed augmented text. With that, we have fused the labels, corresponding label to increase the performance of the model. So then that it is given to the LSTM. So LSTM is trained with the Keras embeddings. So for the second model, that is Embed plus CNN. So here the text, augmented text will be pre-processed, and the features, that is Embed features, will be given to the CNN for the classification. So the augmented samples will be seen here. So original, that only we have increased the minority sample, that is like sarcastic content. Original samples will be augmented by using the NLP aug. And the experiments, we can see it in the table. So here what we have done, we have the result of augmented, that is with augmentation and without augmentation. So when we compared without augmentation, better than that, the with augmentation, it is given a good result. So that itself we have taken for predicting the labels for the test set. So this is the result of validation set, which is given the organizers have provided a train set and development set for checking the performance of the models. So the result of the test set will be seen in the table, the table 7. So here for the Tamil English, we have got with the augmentation, that is 0.74 for Tamil English as well as 0.72 for Malayalam English. To conclude this, when we propose the two of the models, Embed plus CNN has outperformed the LSTM models by getting a macro reference score of 0.74 and 0.72 for Tamil English as well as Malayalam English, securing the first rank in the Tamil English and fourth rank in the Malayalam English. So some of the misclassification, that is because the organizer have even provided the test set with the labels. So we have considered that whatever the predicted label we have submitted, along with that the original label we have compared, and probable reason we have found maybe certain the model might have not trained properly, and whatever the content which will be there for the, what we can say, whatever the actual label may be the non-sarcastic, it might be found as a sarcastic due to certain contextual features. Based on that, or due to the model could not find the proper features during training. So some of the misclassified text we have written in the tables. So as a future work, we'll be working more on the text augmentation, feature extraction, as well as the other learning models. Thank you.
Thank you. First of all, I would like to congratulate the team for getting the first rank in the Tamil English task, right? Congratulations to you. By the way, I have two questions. One is, you said that, I mean, you're doing some augmentation using the BERT. So BERT is basically, and it is going to give a representation of a contextual representation of the input text that you give. How did you use that for doing augmentation?
It's like we are using a NLP org library.
Okay.
So in that, we have one of the method that is contextual word embedding augmenter.
Okay.
So in that augmenter, like we are calling the NLP org library with that contextual word augmenter. So that will be having a creating the original text as a augmented text. Like it will create the
Okay,
the
some
sentence will be
words which is of similar meaning that will be replaced and such kind of things.
yeah, we are not going to replace. The original text will be same, but we are using the insert method, not the substitute method. So the same original text will be there, but the other words will be inserted into the same text.
Okay.
So here we have used a multilingual BERT. So it is like it supports for both Tamil as well as Malayalam. So it remains the same sentence, but it inserts some other hope I can show it. Here we can see some text. That is, this is the original text what we have. So here the some words are inserted, but the original text remains same.
Okay.
So it will remain the semantic meanings, and related to that, it will
So
insert like
related words are going to be inserted into that.
Yes, ma'am.
Yeah, got it. Fine. And the next question is, did you try IndicBERT? So IndicBERT is very good for Indian languages. So did you try that?
We haven't tried.
Right.
We'll,
Yeah, sure. Thank you. Thank you for the nice presentation. I would like to call upon the next team. Sarcasm identification of Dravidian languages, Malayalam and Tamil by D. Thenmozhi.
Good morning, everyone. I'm Thenmozhi from SSN College of Engineering. We have done a work on sarcasm identification of Dravidian languages, Malayalam and Tamil. We all know what is the problem of sarcasm and where it affects. And sarcasm is posing a comment like positive, but it really gives a negative impact, and which affects the applications like sentiment analysis and other things. So it is necessary to overcome, identify the sarcasm and overcome that. And this is the dataset details, dataset provided by the track organizers, and that is for Tamil language, around 21,000 non-sarcastic comments were given and 7,800 sarcastic comments were given. And for Malayalam, around 9,000 non-sarcastic comments and 2,000 something sarcastic comments are given. And it looked like that data set is a little bit having an imbalance problem. I'll let into the methodology what we have used. So we have done quite pre-processing. We removed emoticons like HTTP links and punctuations, and we converted text into lowercase that to reduce the number of features. And we did one thing called as we identified language, what is the language of the given posting, and that we have used it to pre-process it. What we do here is actually in a data, we found some noisy data in other languages also. So we identified that and we removed it from the training data. And we have done one more pre-processing called as the translation, but this we didn't apply to training data. We have employed this for testing data. There also for some testing instances to introduce a noise, a text in other languages also were included. So we applied Google Translator translation library and we translated that other language text into English. So just to improve the performance. And what are the feature extraction technique we used is the count vectorizer with the n-grams, and we set up the parameter to be 1 to 3, which means it considers 1 gram features, 2 gram bigram features as well as trigram features. So all these things were considered as features, and we employed all traditional classifiers. And we did kind of optimization through grid search to find the better performance, that is better parameters for the traditional learning algorithms. And we have, these are the methods that gave better result for our approach for the Malayalam data set. And it's a little bit typo, and that is for logistic regression, we got the F1 score of 0.67. And so that has been taken as the better performed method for us. And again, for Tamil data, once again, the logistic regression gave better result. That's it. We ranked 7th position in both the Tamil and Malayalam text. So this is our work actually. Our contribution relies in the translation part. That's it. And the feature extraction, we did it through count vectorizer with the n-grams, and we make use of the traditional classifiers. And maybe in future to initially what we have done it, we have identified the language and we removed them from the training data. Probably whatever we applied for the test data, like doing translation, if we try to retain them, probably the performance would have been improved. That we need to try it in future, as well as we didn't try for that is it looked like the data is quite imbalanced, and we didn't try any of the data balancing up techniques. So if we do these two things, we expect the performance would have been increased.
Thank you, ma'am. You mean to say that the translation was not performed for the training, but you did it for testing data alone?
Actually, for training, we identified language, what type of language each sentence is having. Because when we see the Tamil English data set, we could find some other language also present in the training data. Maybe to introduce some noise in the data set, those things we found in a very, very small number of instances. So through that language identification, we identified the other languages except the Tamil. In case of Tamil English, we retained all the Tamil English text alone, and we removed the rest of the language text from the training data, and we built the model. But for
okay. So you have, I mean, in the case of the training, you have removed the other language text, but during the testing data, you translated that into English.
English or transliterated,
Okay.
because we can't remove it. We need the number of instances given by the organizers. It should be retained, right? So we can't remove it. And in training data, as more number of instances are there, we just like that removed it, but probably what
Probably the results would have been better if you have
Yeah.
done the same thing in the training data,
Yes.
because those, I mean, other language words may also contribute in
Contributes to-
making the decision of whether it is sarcastic or
Yes,
not.
exactly.
So it is very natural that we may be using some strong words in our own native language or the other domain language. Maybe that would have contributed in increasing the results.
Yeah, we thought that later.
Sure.
Thank you, thank you. Thanks.
Nice. Thank you. One more thing you said, that polyglot library, what is that actually for?
That is used to identify what language is there.
For doing the language
sentence-
identification of the
Sentence is
text.
given even with code mixed text, it is telling whether it is Tamil or Arabic or Telugu, the languages it is identifying.
Okay,
So
just
which
for
helps us
language
to identify the language and retain only the Tamil
Yeah.
English text for that corpus.
Yeah. Thank you. The next presentation is on sarcasm detection in Dravidian languages for Dravidian Code Mix 2024 by the Tech Chasers team. The presentation is going to be given by Samyajit Pal, and he'll be connected online now.
Hello, am I audible?
Yeah, you are.
Okay, so I'll be sharing the screen then.
Yeah, I think it is not visible yet.
Yeah, I'm sharing. Just a minute, okay?
Yeah, sure.
Okay, so is my screen visible?
Yes, it is visible now.
Okay.
Go to the presentation mode, please.
Yeah. So first of all, I would like to thank all the organizers and especially my team for giving me the opportunity to be present here and for being able to finalize the project and for being able to present this paper to everybody. All right. So without further ado, I would directly go to my manuscript. That is the sarcasm detection in Dravidian languages. Our paper ID was 37. So basically what we used is that we used a combination of system architectures and bidirectional GRE for the prediction purposes of the in the code mix dataset provided by the FHIR organization itself. And in that case, we found that the 91% accuracy was found for both the Tamil and the Malayalam datasets, and we ranked 10th and 12th for Tamil and Malayalam respectively. Okay. So I'll just go into the details. This is my team, and I'm Shomajit Paul, the presenter. All right, and the very last row, that is Miss Devoshi Mitra. She has been our mentor from another college, and she helped the most in this paper. And another person was also there. However, we were not able to connect with him properly, but our sir also provided a huge impact towards our project. So our methodology was pretty simple. We first read the data, we reprocessed it, then the model was created, was trained, then the classification report was generated, and finally the models were completed. All right. So the dataset that we used was actually provided by FHIR itself, and we used the both the dev datasets for the Tamil and Malayalam respectively. Right. Here are the dataset. What can I say? Here are the dataset schematics that is given in both the tables, table 1 and table 2. These things, these all the total number of words and total number of sentences, etc., were computed by us, like the basic simple Python code to compute that, just for the sake of understanding, like what we are dealing with, what kind of data we are dealing with, and how much amount of data that we are using. And yes, the non-sarcastic to sarcastic ratio was also found out, so that we can understand the amount of imbalancing present in the data. So for the pre-processing purposes, basically it was pretty simple. We simply removed all the special characters present in the dataset, and tokenization was done for the text. So ensuring that equal length of each equal length tokens are present for each test cases. Padding was introduced if required. And this is our model that we used. Basically, it's a mixture of the main layer that is that we are using is the bidirectional GRU as present here, and then we are using sandwiches between dropouts and LSTMs. And the last one was a fully connected or the dense layer. And yeah, one convolution layer was also present at the very beginning, just for feature extraction purposes. And this was the classification report that was generated by our model for the test data set that was provided. All right. So as we can see that there is a huge imbalancing in the data for the non-sarcastic and sarcastic classes. We did not do anything regarding the imbalancing. We might be doing it in the future purposes. Who knows? Let's see. And that is the reason why the F1 scores of the sarcastic and non-sarcastic for both Tamil and Malayalam are quite different. Like there is a huge difference. Let's say, for example, for the non-sarcastic data, we for both the Tamil and Malayalam we got 0.94. However, for the Tamil one we got the 0.81 for the sarcastic one, and for Malayalam we got 0.71, which is quite lower as compared to 0.94. So that's the case. We should have taken into account the data imbalancing, but we did not. So let's keep it for the future purposes. So as you can see, this is the confusion matrix for the model for accessing the accuracy or the predictions. We use the same model for both the datasets, that is the bidirectional GRU and the sandwiches of LSTM and dropouts and everything that I showed in the previous slides for both the datasets. And the conclusion is that yes, we were able to find out the F1 scores for the Tamil and Malayalam. So non-sarcastic one was 0.94 for the both of them, and for the sarcasm for the sarcastic text, it was 0.81 and 0.71 for Tamil and Malayalam respectively. And so these are the references which has been given in our paper. So thank you.
Thank you, Soumya Jitpal.
Yes, ma'am.
Can you go to the last slide where you are projecting your results?
Yes, sir. This one or this one?
Yeah, whatever it is, both are conveying the same thing. No,
Yes,
the
ma'am.
previous one, the previous one. Yeah, what is, I mean, this result that is it actually showing, that is 0.94, 0.81 for non-sarcastic and sarcastic. If you take an average of it, it is going to be closely 0.888 or something.
Yeah.
Is this meant for the training, training data scores? Because my question is, the final result, the maximum score that was attained was 0.74 that was awarded as the first rank actually.
Yes, ma'am. Yes, ma'am.
For Tamil English, and for Malayalam English, it is 0.76.
Yes,
So the
ma'am.
scores that you are projecting here are just
Yes, ma'am. Yes, ma'am. During after the training, we generated this classification report, not on the test set. That was my bad.
Okay, then you probably would have got these scores for the validation data, I guess. The validation data set was also released, no? So maybe,
Yes, ma'am.
yeah, probably from next time, I mean, you can project the test data results, because that is actually used for evaluation and that is used for ranking also.
Okay, ma'am. Okay, ma'am. I got it.
That is, technically, I have yet another question.
Yes, ma'am.
In your proposed model, I mean, you are using CNN and LSTM, am I right?
Yes, ma'am.
What CNN is used for? Convolution neural networks.
Convolution 1D.
Yeah. What is that? What is the role of that? What are you trying to do? See, there was in the previous presentation, somebody was showing that, I mean, they are using LSTM followed by, or LSTM or some other sequential model followed by convolution neural network for doing the classification task. So
Yes.
you have used the CNN first and LSTM. What is the role of the CNN used here?
Ma'am, what can I say? It's first of all, we first utilized without using a CNN, we first tried to do, but the results were very poor. Alright, so we thought, like, we talked with our mentor and the another person. What I told, they told that yeah, let's see if the introduction of CNN can improve the results. So yeah, we went with the words of our mentor and we just introduced it, and yeah, actually the what can I say, the results were actually much better than the previous ones.
Yeah, maybe you would have used that for doing the feature extraction.
Yes, ma'am. That might be the case. That might
By
be the case.
CNN followed by the LSTM.
Bidirectional GRE, ma'am.
Bidirectional GRU.
Yes, ma'am. After that.
Okay. Okay, thank you so much, Jitpal.
Okay, ma'am. One more thing, what I need to say that my track or like my spot has been what can I say, repeated twice. The 10th paper is also conveying mine. So if the I just don't
Second
want.
paper will also be presented by you.
No, ma'am. It's the same paper. Like it's repeated.
It has been
In the,
repeated twice. In the
repeated in the schedule.
Okay. Okay. Thank you. Thank you for the information.
Okay, ma'am. And can we leave? Can I leave?
Sure, sure. Thank you so much.
Okay. Ma'am.
I would like to call upon Krishna Tevari, who will be presenting the next paper on leveraging ChatGPT and XLM Robota for sarcasm detection in Dravidian code mixed languages.
Good morning, everyone. I'm Krishna Tiwari from Indian Institute of Technology, BHU, and I'm here to present on the paper Leveraging ChatGPT and XLM Robota for Sarcasm Detection in Dravidian Code Mixed Languages. So primarily it is focused on a comparative study between ChatGPT and XLM and fine-tuned XLM Robota. So yeah. So it was a shared task on InFire 2024, where we need to identify and detect sarcasm in code mixed social media text, which was YouTube comments in Dravidian languages. So this is like how the training and the development set and test set was divided. This is how the snapshot of how the data set looked like. So we had primarily two approaches. The first one was ChatGPT, wherein we provided our training file to ChatGPT and gave a prompt based on like train yourself on the input training file, and which is already classified as sarcastic and non-sarcastic. And then we gave testing prompt like along with the test set in a batch of 40 test data. And then we asked it to classify as sarcastic or non-sarcastic. And it was done for both Tamil English and Malayalam English. Our second approach was based on XLM Robota, which was fine-tuned, wherein the hyperparameters were the batch size 16, learning rate of 2e⁻⁵, and epochs were 2. So here we tokenized our sentences and passed on to XLM Robota. And then the output was passed on to different dense layers with a dropout rate of 0.3. And finally, we used softmax to perform the binary classification of sarcastic or non-sarcastic. So based on that, we got first rank in Tamil English with our macro F1 score of 0.74 and third rank in Malayalam English, again with macro F1 score of 0.74. So this is like a comparative study of ChatGPT and XLM Robota, where ChatGPT actually had an F1 score of 0.65 only, while our fine-tuned XLM Robota had an macro F1 score of 0.74. Similarly for Malayalam English. So here we, through the confusion matrix, we can very well understand that ChatGPT wasn't very good at performing the classification of sarcastic versus non-sarcastic as compared to XLM Robota. Similarly for Malayalam English. As a conclusion, I would like to thank the track organizers for this shared task and FIRE 2024. And then I would like to conclude that fine-tuned XLM Robota model outperformed ChatGPT, highlighting the limitations of general purpose models in specialized tasks. And then challenges were due to class imbalance and the nuanced nature of sarcasm, which we would like to deal forward in the future work. Yeah, thank you.
Thank you. Thank you for your interest in participating in this task, though, none of your languages. I hope your language.
No, I'm from Uttar Pradesh, so my language
Yeah,
is
your language is neither Tamil or Malayalam, but I appreciate your interest in applying for this task and doing a submission. Yeah, and moreover, congratulations that you have secured the first rank for the Tamil English task and third rank for the Malayalam English. Sounds great. So I have a few questions. One is, however, you have done the fine tuning of the XLM Robota, you could have fine-tuned the GPT-3 model also. Fine-tuned with the same data set, you could have, because you have directly used the.
Yeah, we just use the zero-shot approach, just give the prompt, provided.
Yeah, you have done the prompting. We have, since you have tried, I'm a bit curious that, since you have fine-tuned your Robota model and then you have done it, fine-tuning GPT-3 would have also given a better result.
Yeah.
So did you try that?
No, we didn't actually try that. That could be our future work. We could try to explore that. Yeah, like you suggested.
Yeah, fine. That is one thing. And second thing is, why were you so choosy about, XLM Robota? It's a multilingual version of the Robota. So you could have even chosen multilingual BERT directly. Did you try that?
Yeah, we tried with MBERT, we tried with Mural, we tried with IndicBERT as well.
Oh.
So, among them, XLM Robota.
XLM Robota was giving you a better results. Oh, you did an initial testing at that. Sounds great. Thank you. The next team who will be presenting here is UMNSH NLP team on sarcasm identification of Dravidian languages, Tamil and Malayalam task. The presenter is James Sedda Flores.
Yes. Good morning, good afternoon. I'm not sure what time it is in India. Can you hear me?
Yeah, you are very much audible here.
Okay, I will share my screen.
Yeah, sure.
Okay.
Yeah, it is visible.
All right. So, hello, my name is Jaime Cerda Flores, and I will be representing the team UMSNH NLP. and I will be presenting our approach to the sarcasm identification task for Dravidian languages. The title of our work is Text Classification Based on Ensembles of Pre-trained Models for Sarcasm Identification in Dravidian Languages. Okay, so to briefly recap, as has already been mentioned, this task focuses on identifying sarcasm in code mixed YouTube comments written in Tamil English and Malayalam English. Excuse my pronunciation. Well, sarcasm detection, automatic sarcasm detection is a challenge in NLP tasks because sarcasm as a form of communication typically relies on context, tone, and visual cues to convey a meaning that is often the opposite of what is literally being said. And this is further complicated when the text being analyzed is in a combination of two or more languages, which is now relatively common given social media and the World Wide Web. The approach proposed by our team follows three main steps visualized in Figure 1, where the first step is text preprocessing, where we clean and prepare text for analysis. Then is model training. This is training multiple text classification models and optimizing them. The outputs of these models are combined to create a new feature space, which is fed into the last step, which is an XGBoost classifier that will make the final prediction of a validation or a test set. And in this figure, the red arrows follow what is the training and validation phases, and the blue arrow follows what is the test phase. And for this approach, we selected several language models to generate outputs for the feature space. These are BERT-based models, which are enlisted in these were Muriel Large, multilingual BERT, XLM Roberta, the base model, and this L3Q Pune BERT that we also found. We also used models obtained through the MicroTC text classification framework, as well as models generated using FastText with its hyperparameter optimization feature. As for the pre-processing we performed, well, it depended on the models that we used. Some of the models were passed through a normalization function in which we did lower casing, white space standardization, punctuation and symbol removal, translating emojis and emoticons into text, removing URLs and changing usernames. This is, as already mentioned, not performed on all models. Some models, specifically some BERT-based models, we instead transliterated the text from the Dravidian script to Latin script, or vice versa. We transliterated all to Dravidian or all to Latin. And these are the model combinations that we used for the final XGBoost classifiers. And it's important to note that each XGBoost classifier was built using randomized search cross-validation using 5-fold stratified k-fold. And out of the experiments we performed, well, these are some of the models that we trained. The top models are individual models with their scores in their respective languages. and the bottom models are the XGBoost ensemble models. Out of these, the models selected to get the final predictions for the test sets are those that we highlighted in bold text. Due to their general higher performance, and in the case of FastText, because of its relative high performance to its speed. And based on these results, I forgot to include that. Yes, we also obtained the first ranking for the Malayalam task for the test set, and we came tied in first rank with other 5 fellow competing teams in the Tamil language using the FastText model. And from these results, we can arrive at the following conclusions regarding our ensemble-based approach. That while, yes, ensembles consistently perform better in validation, during the testing phase, the FastText model performed better. This could be due to possible overfitting, but it requires further investigation. And while this approach is proved to be effective, it is complex and relatively computationally intensive. So further optimization would be needed to simplify this implementation and improve efficiency. And that would be all from me. Thank you.
Thank you, Flores. Thank you for your presentation. I have a few questions, and before that, I would like to thank you for showing interest in joining this shared task. I am a bit curious to know, I mean, what is your motivation for you to participate and do a contribution for Dravidian languages?
Yes. Well, I am a student in a master's degree at the moment, and this system is the focus of my study, the ensemble approach system.
Okay.
And this competition posed, I think, a good challenge to test the system and prove its effectiveness.
Yeah, thank you. I mean, I was a bit curious because you are from Mexico, and then I just want to know how you were very much interested in doing a contribution in this language. Thank you. And my questions, by the way, congratulations for securing the first rank in both Tamil English and Malayalam English. That's a great thing. Thank you. Congratulations to you. And
Thank you very much.
You have used XGBoost classifier, am I right?
Yes.
Why, I mean, why did you choose that? I mean, why were you so biased about choosing such a classifier?
Well, XGBoost has a history of performing well in text classification tasks. Well, machine learning tasks in general. It is something that can be observed in various Kaggle competitions. And well, while doing research, it is an efficient method, but not commonly used as to have a combination of different models. It is taken like, for example, using an entire feature embedding of a single document instead of output of models. So I was curious to see how well it performed given this slightly different approach, because there are more there is more literature on the subject.
Yeah. And the question is, I mean, you would have observed that the data set is imbalanced So did you do anything to handle the imbalance issue?
Yes, I am aware of the data imbalance. Unfortunately, we did not consider data augmentation. I am sure it would have been effective, but at the moment we did not consider it.
Yeah, I mean, you are ranking first, but I mean, score would have increased even further if you have used any of the augmentation techniques. That's a suggestion. Did you try, I mean, any, recent LLM models that are recently proving very much promising? Did you try?
Could you give me an example of these LLM models? I'm afraid we
Yeah.
only tried the enlisted ones.
Yeah, GPT-3, Llama, many LLM models are recently coming up. I mean,
Okay.
I mean, are you working on that?
No, currently it was based more on BERT-based model and a combination of FastText and MicroTC, which is, well, MicroTC is it's a more of a traditional approach. It uses TF-IDF and support vector machine for classification.
Yeah. Okay. Thank you. Thank you so much for joining
My
us.
pleasure. Thank you very much for having me.
Sure. The next presentation is also an online presentation. So it's going to be on a hybrid approach to sarcasm detection in Dravidian code mix text by Dipanja Saha.
Hello, ma'am. Am I audible? Hello?
Yeah, you are. Your screen is
Yeah.
also. Yeah, please.
Okay. Thank you. Okay, so good morning, everyone. My name is Dipanjan Saha, and I am here to present our track paper named Hybrid Approach to Sarcasm Detection in Dravidian Code Mix Text, organized by the Forum for Information Retrieval FIRE 2024. My co-authors are Prashun Maiti and Sainik Kumar Mahata and Dipankar Das. And our team name is JUNLP, and we have secured a rank of 8 in Malayalam and rank 12 in the Tamil language. So regarding the data set, over here, which was provided, if we measure the proportion of sarcastic and non-sarcastic YouTube comments, code mix YouTube comments of the Tamil data set, then for the non-sarcastic part, it is 73.1%, and for the sarcastic part, it is 26.9%. For the and the same in the Malayalam data set was 18.4% for the sarcastic one, and for the non-sarcastic comments, it constituted about 81.6% of the whole data. And also regarding the train tests and the development sets in the Tamil, it was 70% training, 15% testing, and 15% development. And the same was there for the Malayalam dataset also. Now, regarding the system workflow of ours, we start by processing the input comments, the code mix text. Processing means we have done some minimal processing, just like removing the punctuations or the special characters and also converting the text into lower cases. After that, we have used the feature extraction steps using 2 deep learning models. The first one is the CNN, convolutional neural network, and the other one is for the BiLCM, bidirectional LSTM. So, firstly, we have used the CNN layer, which applies the filter to the input text embeddings to produce the feature map. So these feature maps are then reduced in size by the max pooling layer, which we have applied, and which actually it retains the most salient features or the salient local features, for example, the n-gram feature. And the output of this CNN layer is a tensor of certain size. And then coming to the BiLCM one, it is mainly used to capture the long-term dependencies of the text as it is as it is made for. The bidirectional LSTM, it processes the input sequence both from the forward as well as from the backward directions, as instigated from its name. So in the each time step, actually each sequence is an output of a feature vectors. Now, after passing the global max pooling layer, the output is then reduced. I mean, the dimensionality reduction is happening over here. And we will get, and we are getting a single feature vector from this BiLSTM out as an output. After that, we have concatenated the feature vectors of, we have got both from the CNN as well as from the BiLSTM model. And then this concatenated feature vector is then passed on to another machine learning classifier, which name is Adabus. The concatenated feature vector is first normalized or standardized to ensure that all the features contribute equally to the classification process. And then Adabus, why Adabus? Because Adabus uses this concatenated feature vector as an input to its ensemble of weak classifiers. Or in our case, we have used decision tree classifier as its base estimator, and 50 estimators were used in our case. And the Adabus classifier then iteratively learned from these features to build a strong ensemble model so that can classify the text as sarcastic as well as non. And in order to mitigate the overfitting problem, we have used early stopping mechanism, which monitors over the validation loss. I mean, it stops training when the validation loss starts increasing. And then if we move on, these are the system parameters that we have used. The embedding dimensions were 128. The number of filters that we used in LCNN were also 128. The kernel size was 5. A max pooling method was used as a pooling method. Bidirectional LSTM was used. We have used a dropout rate of 0.5%. The number of dense layer units were 128. Adam was used as the optimizer. Batch size was 32. And overall number of epochs were 20. And regarding the system records that we have got, over here, we have got an accuracy of 0.92 for the Tamil dataset overall and 0.96 in the Malayalam. And regarding the F1 score for the non-sarcastic classes, our model has performed better on the Malayalam dataset, Malayalam English dataset, or with an F1 score of 0.97. But for the sarcastic one also, for the Malayalam, we have got 0.89 as the F1 score, whereas 0.83 in case of sarcastic for the Tamil dataset and 0.94 in the non-sarcastic part in the Tamil dataset. This is the confusion matrix that we have, that our models have produced. And if we do error analysis and discussion, so there are certain aspects. The first one was misclassification, because as we have seen that the dataset was clearly imbalanced, but we haven't used any procedure to balance the dataset. That means we haven't used any data augmentation technique or sampling techniques or sampling algorithms. So obviously, higher errors in sarcastic class as due to subtle or indirect sarcasm. So for this, our proposed future work will be to use various transformer models like BERT for a better context understanding. Regarding the class imbalance, we would like to apply data augmentation to balance the classes. For the code mix nature, there were challenges in handling the grammar and syntax variability in Tamil English and Malayalam English. And for this, the future work is to use the pre-trained embeddings tailored for code mix languages. And in the overall scale, high accuracy for non-sarcastic class and effective feature extraction using CNN and BiLSTM. Now, in the proposed future work for this part, we would like to expand the dataset by including more diverse sarcastic examples for a better generalization. So these are some of the references which we have taken. And thank you.
Thank you, Dipanjan Saha. Can you, show the results, what you got it on this data? So whatever that you're projecting here should have been on the training or the validation data set, because the score is 0.94.
Yes, ma'am.
What is the actual result that you got it on the test data?
The test data, ma'am, right now I don't remember. I just remember only the rank.
Your rank is?
Yes, my rank is, and for the Malayalam dataset it was 8, and for the Tamil it was 12.
12, yeah.
Yes.
Yeah, okay. So I was actually, I was also having the same question of why you didn't try using the pre-trained models, but I think you have given it as a future work.
Yes, ma'am. Yes.
Because the contextual informations could have been captured by any of the embedding technique that if you have used. So I think, you have already mentioned all the things that could have improved your system. You have already mentioned in the future work.
Ma'am, we will try. I mean, I have in my mind of trying different sorts of transformers. Actually, the India, which is mainly trained on the Indian languages, so that it performs better. After obviously balancing the data.
Yeah, sure. Sure. Thank you, Dipanja.
Thank you.
Can we close it then? Can we close it? Thank you so much. The sarcasm identification paper presentation track is over now. I would like to take this opportunity to thank the FIRE team and the FIRE organizers for sharing this platform with us to conduct a shared task like this, and that too for the consecutively for the second year too. Thank you for giving this opportunity. I would like you to share our gratitude and thanks to the entire FIRE team. And I think, even before this, we were given the opportunities to conduct some shared task and sentiment analysis also. So thanks for the opportunity given to us.
Thank you. Okay, so now we have free time, and lunch will start at faculty lounge at 12:45. Thank you.
Okay. So like because they are the foreigners, so it's better like if we get today, like we can save them because I think tomorrow at 11 we have a presentation. So I just want to know like if we send it now only and make the arrangement, right? So like we have three online presentations. I don't know whether you guys are sharing that or like we have to share it to the participants and who are doing online presentation. And those are from like foreigners. Right? So we don't know at what time they are available. And their timing and our timing is different, right? So we have to send them
Immediately. So I will share you the link of Zoom meeting, or you can share it.
Yeah.
So,
Those are mine only. Okay, mail, Gmail. Okay. Okay, yeah, that's okay. Because on the Gmail I was not getting anything, and then later I came to my way wrong the mail. A was missing.
Yeah. Hi everyone. Thank you for coming. Hope you enjoyed your lunch. So we'll be starting with trick presentations for Indian language summarization task. I just want to repeat a couple of instructions for all the presenters. We have already covered the details of data sets and tasks. So yeah, probably try to avoid going into data set statistics or like task descriptions. And I'll suggest you to give more emphasis to your methodology and results. The duration for each presentation is 5 minutes. So please try to adhere to timeline. Yeah. So with that, we'll start with the first presentation by Aniket on cross-factual, a novel approach for detecting factual inaccuracies in machine-generated summaries. This one.
Thank you. So I will present cross-factual, a novel approach for detecting factual inaccuracies in machine-generated summaries by Aniket and Subhankar. So let's give a bit introduction. So the task of factual inaccuracy detection is a novel and challenging task in multilingual context as automated summarization techniques advance, ensuring the reliability of generated content becomes increasingly critical, especially when the output is intended for diverse language speakers. The study focuses on identifying factual errors in summaries produced from English source documents, specifically targeting Hindi and Gujarati language. So the data set, we primarily focused on the test set, 200 article summary pairs for Gujarati and Hindi language. Task definition was to find out 5 types of inaccuracies: misrepresentation, false attribution, incorrect quantities, fabrication, or whether it is correct, whether the summaries are correct with respect to the source documents. So this was the prompt that we used for the misrepresentation class. So we give the definition of the misrepresentation class, and then after giving the definition of the misrepresentation class, we ask the model whether the corresponding article and summary belong to the misrepresentation class and ask the model to state yes or no. Similarly, for incorrect quantities class, we use this definition of the incorrect quantities class and then ask the model to give whether the article summary pair belongs to the misrepresentation class or not. In the same way, we used a prompt for the false attribution class, and we gave the article summary pair to the GPT 3.5 Turbo model and asked the model to check whether it belongs to the false attribution class or not. Similarly, we gave a prompt for the fabrication class, and we asked similarly to check whether the article summary pair belongs to the fabrication class or not. So we arrange these prompts in the form of simple algorithms. First, we check for the fabrication class, then we check for the false attribution class, then for the incorrect quantities class. And if none of them are true, we say that it is correct, and we perform the same for every data point. Similarly, algorithm 2 is just a different arrangement of the same thing. First, starting with the fabrication class, then misrepresentation class, then false attribution class, and then incorrect quantities class. Then the third algorithm is again a different arrangement of the 4 different types of misclassifications: first false attribution, then misrepresentation, then fabrication, and then incorrect quantities. The fourth algorithm is again another arrangement, first starting with incorrect quantities, then misrepresentation, then false attribution, and then fabrication. Next is the ensemble approach that we tried. We tried all the 4 the algorithms, and then we ran at 3 different temperature values, and we considered the majority voting amongst the data points. Next is the ranks results for Gujarati language. So results are not that good according to our approach. These are the 5 results. Next is the results for Hindi language, which are also not that good for Hindi language. Next is the conclusion. So the highest score obtained was 0.0677 for the F1 score in Hindi and Gujarati. Despite the advancement, the overall scores needs to be improved quite further. And there are persistent challenges in developing robust models for detecting factual inaccuracies. The results underscore the need for further research and refinement to enhance the effectiveness of detection systems in the future. Thank you.
Thank you. Any questions? Yeah, thank you, Aniket.
Thank
So, yeah. Next presentation we have is titled Text Summarization and Detection of Factual Incorrectness for Indian Languages.
Good afternoon, everyone. I'm Tenuri again, presenting work on text summarization. Maybe as the organizer said, I need not explain what is summarization and other things. Directly, I'll get into what are the approaches we have used. So for task one, text summarization for Indian languages, the data set given for 4 languages is this data distribution. And I'll get into the implementation, what we have done. And we have cleaned the articles to remove unnecessary white spaces and line breaks for consistent input. And we have chosen the models like a BART model, T5, MT5, and its variant MT5, M2M cross sum. So among this, this MT5, M2M cross sum performs better for multilingual summarization. And these are the hyperparameters we used. Okay, so we have set the input length to 512 tokens and summary length to be 84 tokens. And we use the beam search method with the 4 beams. And then the no repeat n-gram size we have set to 2 here. And target language set via decoder start token ID. And for tokenizer, we used MT5 tokenizer. And for evaluation, it has been evaluated using ROGUE scores. So these are the scores we obtained for this the best model what we have claimed, that is MT5 M2M cross sum model. Okay, and that is as this MT5 model is a multilingual T5 model, and this is best suitable for the summarization of Indian languages. And this M2M cross sum is a model trained for cross-lingual summarization basically, but that works pretty good for the summarization task. So this is our work. Thank you.
Any questions? I think we can do the continuation of
Yes,
second
thank you.
presentation itself.
Sorry, I didn't complete the other part of the same work.
Sure, please go
Which is task 2. We have submitted runs for task 2 also. So okay, I will skip this data set part, and this is the data. This is the data set given. If we see here, so that is for particular class, there are more instances given. Example, for the correct summaries, 3,986 instances were given, but for the other classes, the lesser size. So what we have done it, we have used the SMOTE techniques to balance the data. And then all other things are as usual. So we have employed the TF-IDF factorizer. But we have done a pre-process by combining or by merging the articles like incorrect summaries in Gujarati, incorrect summary in Hindi, everything into one textual frame. So as a combined frame, we extracted features using TF-IDF, and we employed the traditional classifiers in ensemble classifiers. And for these classifiers, the parameters are tuned by using a grid search method only. And we have got the macro FM score for Hindi to be this and Gujarati is 0.296. And our team did almost it secured 6th to 9th rank only, so not much good performance. So that's it. And when we observe the results, most of the correct, that is, some of the few summaries were incorrectly predicted, but all the incorrect summaries were correctly predicted as incorrect summaries. Yes, sir.
It seems to be very good, right? I mean, it doesn't.
But this 42, that 35 and all. Most
But
of
it,
the
it
things.
still doesn't correlate well with your F score, like low F score. This is quite good actually. And this is for what language?
This is, sorry, sir. Training data on the validation set we predicted for Hindi language. I think.
Validation set or train set?
Validation
Okay,
set
this is after training.
After training. Maybe this implementation part right now I'm not able to clearly explain because done by students, some represented students.
No problem. We can talk offline.
Yes, sir.
Thank you.
This is summarization of English language using two pre-trained models, T5 and the Google Gemini 1.0 Pro model. So here the important feature extract, that is pre-processing technique, what we have done is we have removed the non-ASCII characters and we have replaced some unreadable Unicode characters. So these are the important pre-processing techniques we applied. And then we used the Google Gemini 1.0 Pro version, and which is a sequence to sequence modeling based on the attention mechanism that is pre-trained on the large data sets. So we have fine-tuned our data with that model. And the other model, what we have used is the regular T5 model, and which is basically encoded decoder framework. And we have used some parameters like we used a T5 base model, not the large model. And minimum 50 words we set and maximum 75 words we have kept. And with the number of beams to be 15, the length penalty, what we have set is 1.3, and no repeat n-gram size setting is 5. Then we obtain, that is this particular Gemini model, the BERT score was better when we compared with our two approaches. And when we take our ROGUE score, T5 model performs better. And altogether, we have secured 6th rank in this particular task.
Yeah, any questions? Yeah.
Thank you.
Thanks a lot. Next we have is Abhijit, will be joining us virtually. Abhijit, are you there?
Yeah, good afternoon, sir.
Yeah, hi. So you need to share your screen, and if you can make yourself visible, that will be better.
Am I audible now?
Yes.
Yeah, good afternoon, sir. Myself, Abhijit Balan from NIT Trichy, on the behalf of Curious Coders. So these are my agenda: problem statement, introduction, approach, result, and conclusion. Problem statement task one was summarization. We were given some of the languages like Tamil, Telugu, and Indian languages. And next was factual error detection. English, source language English, and Hindi and Gujarati was the target. So these were the classes of error type. So these are general introductions about text summarization and their classes like extractive and abstractive. So our approach was task one. We fine-tuned the MT5 multilingual Excel sum model for Indian languages, but we faced some difficulty for the language of Kannada. So in Kannada language, we have done a workflow of translation first from English, then we translated to either Hindi language like that. So a translation module was needed for summarization for Kannada. Then factual error, we taken help of Llama 3. In Llama 3, we have given a prompt. Based on the prompt, we have classified the error as misrepresentation, inaccurate quantities, false attribution, like that. So in second work, we have taken Llama 3 with a temperature value of 0 and little bit hyperparameter tuning. Usually, um, due to hardware restrictions, also we have taken quantized model such as even we had tried for other models like Pi, Llama 2 as well. So basically, these are the result. Task one we had taken BERT as well as Raw score. Still, it needs some of the improvement. And F1 score for the task two work. For Gujarati, we have scored 5 and Hindi, we scored 7. That we can still improve the F1 score. So, in conclusion, we faced we taken MT5 and Llama 3 was better model in comparison to for the first task. MT5 was better model and Llama 3 was better model for factual error detection. And the second thing, due to linguistic diversity, we faced little bit challenges like some of the embedding models were not available. So we had to do translation work and even better result we can get by uh, more pre-processing and doing even more embedding work with the model. So in my future work, we are thinking of to use IndicBART and BERT and Roberta models as well, and to do as a multimodal summarization technique, even with text audio. So these are our things. Any questions?
Any questions? Yeah, thank you, Abhijit. Yeah. Next we have is Pulkit, who is also joining us virtually. Pulkit, are you there?
Yes, sir.
Probably you can present your screen and yeah.
So it would take 2 minutes actually.
Sure.
So are you able to see my screen?
It's visible.
Sir, actually I need 2 minutes. Oh,
not visible now. Oh, sure, sure. Pulkit will take you next. I think we'll take the next presentation now.
Okay, sir.
So, Sangeeta, are you there? Oh, all right. Oh, all right. Then Pulkit, you can try to make it as soon as possible.
Yes, sir. Yes. Good afternoon, all. I'm hello.
Your screen is visible, but I think your voice is breaking.
Oh, hello.
Yeah, I think you are audible now.
Okay, sir. Good afternoon. My name is Pulkit Chitwal and I am from Team Data Lovers. So this is the overview of our presentation. How will I lead my presentation? First of all, the introduction. I have participated in the task one of the Indian language summarization. Overall, there were 7 languages. I have participated in the 6 languages. The background of the problem is that in previous year the ILSAM task provided three languages. Now they have provided more Dravidian languages. So for it, we have studied the past papers to lead our approaches. The key challenges were the code mixing, the script mixing, as you all know. Our methodology was to fine tuning the 3 models. We decided to choose different models for different languages. For Gujarati, Telugu, and Bengali, we have chosen MT5, and for Hindi and Tamil, we choose IndigWord. And for the English, we have chosen the BERT model. We have fine-tuned this model, and especially for English, we have also tried another technique called prompt engineering with a zero-shot prompt engineering, where we have got good results, but the fine-tuning result was better than the fine-tuning result was better than the prompt engineering result, but it was not as good as exceptional comparative to the prompt engineering method. Our results were exceptionally good. We achieved first place in the 5 languages and second place in the Telugu language. Our results was very good, but in our future work, we are planning to fine tune 3 models: GPT-4, Llama 3, and Bloom. And we are also thinking about to advance in our prompt engineering methodology with chain of thoughts and chain of thoughts, few shots, and meta learning. Oh, thank you.
Yeah.
Any questions?
Yeah, any question? Yeah, I have one question. Did you try to analyze the generations manually?
Yes, sir. Yes, sir.
And so there is this code mixing challenge, right? So were you able to successfully generate like such code mixed summaries, or?
Yes, sir. Yes, sir. We are able to generate the code mixing summaries.
All right. Yeah. Yeah, that's all. Thank you.
Thank you, sir.
Yeah, I think with that, we are concluding the track presentations for Indian language summarization today. We have a keynote starting from 2:30 p.m. So yeah, you can take another break now probably.
डाउनलोड्स में आ जाएगा हाँ स्क्रीन शेयरिंग में आ जाएगा ना राइट शो राइट शो ये चल रहा है क्या चल रहा है
Like the identical model. Yeah, they're both quite faint. Like so, like that. Mine is slightly brighter.
Okay.
Okay. Thanks, Ajay.
Hello, hello. Yes. I am supposed to introduce Showman for his session. I don't think he needs an introduction. He's so famous in the computer science community. But for those who are kind of students, those who don't know Showman is a scientist of highest category, I will say. And once I invited him to give a seminar, so I told Showman, please talk at a level which I can understand or others can understand. Showman said, it's Tathagata, it's easy. I will understand everything. But after 5 minutes, everything goes above my head.
I don't know if that's a good certificate or a bad one.
So, but he is a great scientist in the, everybody knows, and he also developed a lot of good students who are basically now also very famous. So now it's Showman to you. That one is yours.
Thanks. It's a pleasure to be here. Hopefully, I'll rise a little above that level in my teaching skills. So I'm really regarding this more as a discussion or conversation, not really my work per se. And also most of it is work by many collaborators, and I'm just a messenger. So in this talk, I will try to draw some lessons from dense and sparse text retrieval in recent years, and then try to transfer it to graph search and graph matching. I'll try to give some motivating applications along the way, but most of the discussion will be at a conceptual level. For those of you who are practitioners of information retrieval, we know that in recent years, dense retrieval has supplemented and sometimes overtaken sparse inverted index-based text retrieval. In a prototypical dense retrieval situation, we have a query or a passage, Q or X, which is a token sequence. Unlike old-style information retrieval, these token sequences may be somewhat longer than one sentence, but are typically much shorter than whole documents. And each of them can be input to a contextual encoder. So again, for those of you who may not be familiar with it, although in FHIR I expect most people might be, a contextual encoder may be based on a transformer network, or it may be based on an LSTM kind of network, whatever it is. It takes in words one at a time. It inputs context-independent word embeddings for each of those words, and then it munges them together to come up with a vector for each word position, which is, however, qualified by information in the whole passage. For example, if instead of where was Einstein born, if the statement was who swam along the bank of the river, then the meaning of bank at the input would be the same as some other sentence, which is I went to the bank to deposit some cash. But at the output, thanks to the other words, their contextual representations will change. And the first one will mean a river bank, and the second one will mean a financial bank. Okay? So that's what a contextual encoder does. So a contextual encoder is capable of usually outputting one vector per token position, but by injecting a synthetic token, usually called CLS, it can also be made to output a vector which basically summarizes or compresses the contents of the whole passage in it. Now, each of these vectors typically has a fixed length, 768 being the new Planck's constant. But the size of these sets, the Q set and the X set, may of course be different. The passage will typically be a bit longer than the question itself. Now, armed with this, it's efficient and simple to build what is called a late interaction retrieval framework, or a dual encoder framework, where these two encoders encode the question and the passage to Q0 and X0 vectors, respectively. And then the document X is scored with respect to the query Q, that's the score S of X given Q, by a little network F. It may not even be a network. It may just be a dot product between Q0 and X0 as vectors. Or it could be the cosine of the angle between the two vectors, just to judge how similar those things are, right? So very often, F is actually a symmetric function. And that may work for information retrieval. It may not work for some other tasks, like textual entailment, right? Because that's inherently asymmetric. If sentence X implies sentence Q, that's different from sentence Q implying sentence X. And you shouldn't be comparing it with a symmetric function. In any case, the nice part about this simple functions F is that you can design efficient indices. Inverted indexes are super optimized with compression and decompression on the fly and merging and all that. And some of that was lost when people moved to dense indexing. But you can have things like locality sensitive hash functions or hierarchical networks to restore some of the scalability of search into the system. On the other hand, ignoring these context sensitive word vectors, Q1 through QM or X1 through Xn, is not the best choice when it comes to accuracy of the system. Because there's too much lossy compression going on, summarizing or compressing the entire meaning of passages into single vectors doesn't work out that well. On the other extreme, the choice that works very well with regard to ranking accuracy is what's called an early interaction network or a cross encoder. So observe that the gap in the middle is gone, and the query concatenated with the passage is simultaneously input into the joint or cross encoder. And the CLS embedding Q0 now changes its meaning. Earlier, it was the compressed meaning of the two respective passages, question or passage. Now it's passing judgment on whether X satisfies query Q or not. And that signal is extracted by a real network, typically ending in like a logistic scoring module, which tells you how satisfactory is X for answering Q. Okay. So this gives way better ranking performance than dual encoders, as we shall see, and has been reported many times. But the disadvantage is it's not obviously amenable to fast indexing, because every candidate X has to be juxtaposed with Q in turn and fed into this joint contextual encoder, right? So that cross-word associations can be discovered and built between any pair of words between X and Q. So, so this was the state of affairs for a little while until this very interesting proposal Colbert, which many of you know about, which is a nice compromise between these two worlds. So Colbert does allow contextualization within the question and the passage, but it's not so simplistic as to just take two vectors and compare it. Instead of collapsing X and Q into single vectors, it builds a crossbar of vectors. So the question is, where was Einstein born? And the candidate passage is Einstein, comma, a native of Ulm, comma, dot, 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 etc. Right? So, and every element of that matrix could be some kind of a similarity, S between QM and XN. That similarity might be a symmetric similarity. That's what Colbert originally proposed. That doesn't work for all applications, and we'll get into that in a moment. But you see that Einstein matches Einstein strongly. That similarity is very dark. And then there are fainter colors all over the matrix. And now, each query token vector QM, that's a row, tries to find its best supporting partner across the columns. So Einstein is presumably best supported by Einstein. It's largely context independent. On the other hand, we expect the magic of word embeddings and deep learning to bridge the syntax gap between where born and native of, or was born, right? So that's the kind of behavior we are expecting over the matrix. Observe that one passage token may cover multiple question tokens. That's perfectly permissible. Contextualization does survive, but within the question and within the passage separately. There's no contextualization across the two. So it does give up a little bit. Experimentally, it doesn't seem to hurt much in standard benchmarks. We'll come back in a moment to this question of how do we know that where should match Ulm? After all, Ulm is a location and where hints at a location, but where itself is not a location. So what builds similarity between these two? And that's the job of fine-tuning. Okay. But one could think of this as we are trying to discover a vector analog of is a set Q a subset of the set X, right? So if everything in Q is covered with some very similar thing in X, then this is a form of soft set containment. So that was our initial take on Colbert, that it's a way to do soft set containment. And then we started embellishing it in different directions to deal with graph problems. Now, of course, many of you know that Colbert led to a flurry of work, and by now Colbert is not that competitive. There are better systems like Splade and others, Flops and Splade. Okay. So now, Colbert does hit a very sweet spot in terms of query latency versus ranking performance. And this is from their paper. So at the bottom here, you see the dual encoders involving late interaction. So those are very fast. So query latency is very small. So that's nice. But their MRRs are not that great. They're all better than BM25 after fine tuning, but They're not that great. Okay. If we use cross encoders, BART large, BART base, then you get a huge boost in MRR, but at the cost of several orders of magnitude slower query processing because of the contextualization. One can try various tricks like first filter through BM25, etc., but then any syntax gap which makes you lose recall in the first stage is irrevocable. Those documents are lost, and so you may never recover from them fully. So Colbert hits this very sweet spot where it's almost as good as cross encoders at almost the speed of BM25. So that's really nice, and that's what catapulted those people to fame, right? And then this kind of fine-tuning. The other thing is that Colbert can support some kind of fine-tuning through this retrieval process, and we can use triplet loss, like the score of a positive document given the query should be much larger than a negative document given the query. You could read the D's as X's. That would be the best thing to do. And then fine-tuning here may help to learn that where should match with Ulm and other locations. Is that how things actually work? Well, there's this area of mechanistic interpretation which tries to figure that out. But I don't think people have done a very comprehensive study of that. Now, so the first thing we'll do is simplify our lives a bit by disallowing one-to-many or many-to-many or many-to-one assignments for the purposes of graph matching. And if necessary, we will pad the smaller side of Q and X, typically Q, with some dummy words, with some dummy vectors, so that both sides have exactly the same length, and we'll set the similarities in a way that doesn't interfere with our optimization. So here's an example. X is a boy playing on a beach, threw a frisbee at his dog who promptly caught it. And Q says a Dalmatian played with a toy next to an ocean. Right? Now, there is definitely a lot of similarity between these. And one might ask, does X imply Q? Right? So there are some things in favor and some things against. X just said a dog. You cannot necessarily infer Dalmatian out of it. But if it were the other way around, then it would be fine. If I said, boy playing on the beach threw a frisbee at his Dalmatian who promptly caught it, then sure, there's a dog playing with a toy next to a beach, right? So there's a certain asymmetry even within the words. So S itself is in a bit of a trouble, but let's give that the slip for another couple of slides and go along with this, right? So if I ask, does X imply Q? If we have deep faith in contextual embedding by deep networks, then we could say that we'll reduce the judgment of sentence-to-sentence implication by a soft set containment test, right? And it's not a hard set containment. The elements of the set are not discrete elements with IDs that you can deterministically compare. The elements of the set are themselves soft vectors. Okay? So that's the situation. So now, suppose we say, well, what are we really after? So the lengths here are different, but I assumed Q is padded and so on. In that case, we'd be looking for a suitable permutation pi among all the n factorial permutations between these two sets. And then we'll define the score of X implying Q as something like the max over all possible permutations, and then the sum over the pairwise similarities between assigned pairs. So it's like a maximum matching problem. Okay. And we'll somehow, I'll often overload the notation. We'll sometimes call X and Q as sets of vectors. Sometimes we'll call them matrices. It should be reasonably clear from context. If I'm not making sense, please feel free to interrupt and I'll try to clean it up. So because we'll be working with these matrices, like n tokens each with d-dimensional embeddings, we will find it convenient to turn permutations from the standard permutation notation to matrices. So if pi maps 1 to 3, 2 to 1, and 3 to 2, that is equivalently written by a P matrix where the first column has 1 in the third position, the second one in the first position, the third column in the second position. So that's a permutation matrix. Of course, by definition, every row and column of P has exactly 1, 1. Now, if you take any matrix X like the colored matrix over there and pre-multiplied by P, you'll actually implement this permutation, right? So what will happen is the first row will go to the third row, right? The second row will go to the first row, and so that's a standard way in which permutations operate on matrices. Also, I won't show a cartoon for that. If you take any n by n other matrix A, which could be a matrix of reals, if pi is applied to shuffle its rows and columns consistently, that's the equivalent of writing PA P transpose. Okay, so you take a matrix, pre-multiply, post-multiply, rows and columns are shuffled around. In particular, if A is an adjacency matrix of a graph, then PA P transpose is the same graph presented in a different order of nodes. That's all. Okay. So this is all fine, but observe that Colbert didn't actually have any learning in choosing the assignment. This is actually not really learning. It's greedily saying the overall score is the sum over all query tokens, the score of the best partners match. Right? What if we wanted to actually find a permutation which was not possibly many-to-many? Right? Then say we want to do it through a neural network, you would have to output a permutation matrix. Even if you didn't want to use a neural network and you're still stuck in 2005, how many possible labels are there? N factorial permutations to choose from. You have to identify one of them, right? So in those days, it used to be called structured prediction, right? Because you're trying to predict a bunch of labels, but they're strongly coupled to each other, and you cannot just take independent decisions. So for decades, a single multinomial distribution was all that neural networks could model as an output. This is right from digit and character recognition to LLMs. Even LLMs today, all that they can do is sample a multinomial distribution for the next token. Right? Unlike these graphical models, whose very purpose was to model constraint joint distributions. So very little of that has actually percolated into deep learning, surprisingly, over the last 10 years. One of them is permutation matrices. So one way to ask the question is, suppose I give you a square matrix of similarities. It may not be symmetric also. Okay. What is the closest permutation matrix to it? And one way to formulate it is to say, find me a permutation matrix which maximizes an element-wise dot product over the matrices, which is the same as trace of P transpose S. Okay. So this is a form of an assignment problem, although assignment is usually cast as a minimization and not a maximization, but it's very similar. Now, if you wanted to, for some reason, relax this to a real valued permutation, why might we want to do that? Because we might want to backpropagate through the permutation finder to the encoder itself, just like you could do with Colbert. So the real relaxation of a permutation matrix is a doubly stochastic matrix. So a doubly stochastic matrix is a matrix of non-negative reals, so that each row and each column adds up to 1. It's also called a soft permutation. We will overload notation. Sometimes this fancy script Pn will mean the space of stochastic matrices. Sometimes it will mean permutations, so hard or soft permutations. Hopefully, it will be clear from context. Now, a problem which is very close to this is discrete optimal transport. So instead of similarities, suppose we characterize this crossbar matrix with distances, d, between qm and xm. And this d could be defined in any way that's consistent with the similarities. For example, I could take arc cos of the angle between the two vectors, qm and xm. I could do a whole bunch of things like that. Or I could take L2 distance, although L2 distance in high dimensions is rarely meaningful. So you could think the cost of transporting unit goods between m and n is that d, qm, xm. Our decision variables will be reals, zmn, which is the number of units of goods that I will transport from m to n. And that should be subject to various margin constraints. Like there's a certain supply on the rows and there's a certain demand on the columns, or the other way around, it's kind of symmetric. So, so different variations of this are called by different names in communities. The operations research community often calls this optimal transport. There are many other names for this. So this has been rediscovered in many, many communities again and again. So you're trying to minimize the total cost of transportation, Z times D, while satisfying supply and demand. Of course, total supply has to equal total demand. This is a simple linear program. It's easily solved. Your supply and demand might be set using a uniform distribution, but more commonly, you might base it on word rarity. You might really want Einstein to be transported as compared to was. You could tune things that way. So now we have at least two families of approaches to this. Instead of Colbert, we could either use a Hungarian method for assignment, or we could solve this LP. Neither of these satisfied our requirement that we would need to fine-tune the encoder itself through this process. So that's where somehow smoothing the permutation comes into play. So why do we want to use a differential assignment solver? We'd like to fine-tune things like this. Where was Einstein born? Where should match locations? That would be really handy. And soon we will use this differentiability to train not word encoding networks, but graph neural networks. We'll see that within a few slides. So to approach that, let's take a 1-minute detour into something that many of you know, but maybe it will be new to some of you at least. So suppose I have a real vector S with elements 3, 5, and -2. And I just want to find the maximum. Obviously, the maximum is 5. So if I say max of n Sn, the answer is just 5. I'll rewrite it in a fancy way by introducing a vector z, which is over the unit simplex. What's the unit simplex? Z is non-negative, and the elements of z are up to 1. Okay. So it has n-1 degrees of freedom, and it's written as delta to the n-1. I would like to maximize z dot s. It's the same problem, because I want to concentrate the whole weight of z at the 5 position, so I get 5 back. Now consider the variation where I keep that old dot product as an objective, but I add some tau hyperparameter times the entropy of the z distribution to it. So sum over n minus zn log zn. So we add tau times hz, the entropy of z. Now, through a simple Lagrangian optimization, you can find that this time, the optimal values of zn will be e to the power Sn over tau. And this basically recovers softmax. So what is softmax? Softmax is the quest for the maximum while keeping z as flat as possible. That is basically what softmax is, right? So with that known at this point, we get to the essence of this, which was reported since the 60s or 70s, but rediscovered in 2013 by Marco Couturi, which is called the Sinkhorn-Knopp iterations. So remember, our goal was to find a permutation P star, which was closest in an inner product sense to the similarity matrix S. Right? So we initialize P0 to be e to the power S over tau, where tau is some temperature. And then we iteratively alternate between these two half steps. First, we row normalize P of t, then we column normalize the result, and that gives me Pt plus 1. So we keep normalizing this. So Sinkhorn and Knopp showed that number one, limit t tends to infinity, Pt is doubly stochastic. So it is a relaxation of a permutation. But second, it actually solves the argmax of what we set out to do plus the entropy of the P matrix. So it's the direct two-dimensional generalization of softmax. It's a very, very neat result. Now, why is this useful to a neural networks type person? Right? if you fancy yourself as such. The idea is that for any finite depth T, this is basically a very simple computation network. It's like layer norm, something like that, right? So therefore, you can backprop through these normalization layers into the encoder. And that's where the power comes from. Now, coming back to this issue of Dalmatian versus dog. So far, we knew that there is asymmetry between Q being a subset of X and X being a subset of Q, but the component similarity score, small s, between Qm and Xn, that was considered to be symmetric. It might have been cosine, it might have been dot product, or if we don't like both positive and negative values, we could somehow shift it with a sigmoid or something like that. But the elements were compared by a symmetric function, S. But in text and graphs, even this S may be asymmetric. Dog in a query may match hound in a passage one way, but not the other way, like I was saying in text entailment. Or you might have two graphs, and node U in one graph may want to match node U prime in the other graph, because the node neighborhood of U is subgraph isomorphic to the neighborhood of U prime. Okay. So when graph G is a subgraph of G prime, that doesn't mean G prime is a subgraph of G. Of course, it's asymmetric, right? So for all these reasons, we might need to even model asymmetry in comparing the elements of the set, the vectors themselves. So here's the example. Somehow the Dalmatian has turned into a hound. I don't know how that happened. A boy playing on a beach threw a frisbee at his hound, who promptly caught it. And then Q is a dog played with a toy next to an ocean. So now you might argue that this is okay. X implies Q because beach is a part of an ocean or it's near an ocean. Okay, so it's morphing here. So dog is an instance of pet or something like that, right? Caught is one form of played with. And so people have thought about this for a while, since at least 2016, 17-ish. We have one paper on this. And the result is what's called this order or rectangle embeddings. So this is what I mean. So suppose people is embedded to this point in 2 dimensions, in general in high dimensions. And that means that if you take the positive orthorhombic aligned cone cornered at this point, all points inside that cone are people. Okay. In that case, any subset of people, such as actor, has to be a cone which is contained in that cone. Right? And similarly, we have politicians in the green cone and actors in the red cone. And somehow these cones overlap a lot. Well, a lot of politicians are actors. So here's one illustrious example. Right? So, and we can write this down as, set I is contained in set J if the embedding of I dominates the embedding of J element-wise vectors. Okay. So this can be taught. So deep networks can actually learn to fit text encoders, for example, so that I always get the order wrong. In a text entailment, one of the sentence vectors will dominate the other sentence vector. And you can judge implication based on that dominance. So given this, our S, so to speak, is now no longer symmetric. So now we might say that, if I want to judge if Q is a subset of X as soft sets, I'll create a distance function, d of X given Q, which is like a distance that catches violation of Q in X. So if Q is indeed a subset of X, then D should be 0. Okay. Now, of course, this is asymmetric, and it depends on a given P, the permutation between X and Q. A reasonable proposal is the following. Given a permutation P, I will judge the distance, and this is not really a metric distance, not symmetric. I'll judge the distance from Q being contained in X as, let's go in slow motion, sum over all the elements in the 2 sets, right? Sum over all these dimensions. I'll take a particular vector, blue vector in Q. I'll see what pi or P maps it to, that row. I'll subtract green from blue. And if blue is dominated by green, and therefore Q minus Px plus turns to 0. So this is ReLU basically, right? Think bracket under plus means max of 0 and that. So if blue minus green is negative element-wise, then this goes to 0, and then there's no distance. So if Q is contained in X, there must exist a permutation so that every row here is dominated by its mapped row in the right-hand side. So that's my definition of soft set containment. Its dominance under a permutation. And then you quantify over the permutation and say, I want to minimize the distance over P's. And that gives me the soft set containment score. So this is asymmetric, and it seems really unfriendly to indexing. But last year we had a very nice result in NeurIPS where we showed that you can actually design a hash function for this by actually lifting this to a Fourier domain and then doing dot product in the Fourier domain. So that's a nice result. I won't talk about that today. Now, the other reason why we would like to do this is that we don't want to supervise these things too closely, right? I mean, in information retrieval, the best thing you can expect is relevance judgments of whole passages. Even that is hard to come by. No one will give you these permutations as certificates of why something is relevant and something is not relevant. So any learning system has to induce the permutations on its own. So if here's a Q, a pet played with a toy next to an ocean, X plus is boy played on a beach, right? And X minus is a dog chased a boy stealing a baseball. Right? So X plus implies Q, X minus does not imply Q. And so we can do standard triplet-like training, that the distance of the positive person, even with margin added, has to be much less than the distance of the negative. So optimal permutations P plus and P minus will not be provided for training. It's too much work. All we know is that there exists a P plus for which D of X plus is small, but no matter what P minus you pick, D of X minus will be large. And this is inherently non-convex. You can't really do much about it. So now we come to, now that the whole setup is done, let's talk about graph problems. Any questions up to this point? Oh, there's no clock here. It's dangerous. How many minutes in are we? Right. So that's a good point. So once you have a contextual encoder firing up on a passage, the hope is that the encoder has done its job of capturing the meaning of the order. And now those vectors can be dealt with as a set. Not always true. We have seen cases where Colbert makes bad mistakes because of unordered matchings. Okay. So now we come to subgraph isomorphism. So GQ is the query graph. GC plus is a positive or relevant corpus graph, because obviously you can embed A, B, C, D into A prime, B prime, C prime, and D prime with all edges reserved, right? Wherever there is an edge there, there must be an edge here. There could be other extra edges, given the node permutation. However, GC minus is an irrelevant graph because GQ is not a subgraph of GC minus. So the decision problem of subgraph isomorphism is very hairy. Graph isomorphism is known to be hard, but subgraph isomorphism, the status is not even clear. Very iffy, right? So, so we're not even talking about worst case complexity here. The question is, for applications, what is really required? For search applications, you're not so much looking for a decision about whether something is subgraph isomorphic or not, rather than rank the corpus in terms of how close it comes to containing the query graph. This is very common in, say, knowledge graph search. You start off with a query saying, how did Barack Obama's father die? And that's basically an incomplete graph, and you'd like to embed that into the knowledge graph to instantiate the unknown nodes and edges. Right? So it has a flavor of this, and that's what we are after. So now, of course, if you look at the adjacency matrix of the graph, reordering the nodes doesn't change the meaning of the graph. And if P is a node permutation matrix, then PAP transpose represents row and column permuted adjacency matrix. Now, if we say that GQ is a subgraph of GC plus, which we will sometimes write just as a subset, what we mean is a subset in the edge sense, that wherever AQ has a UV that's connected, its corresponding permutation in PAC plus P transpose should have an edge. Any edge in the query graph has to be covered by a corresponding edge in the corpus graph if we have claimed node-to-node correspondence. Okay. So this is what we want, and this is easily turned into some kind of a ReLU to judge how far we are from subgraph isomorphism. So if UV is in EQ, then pi of U, pi of V has to be in EC plus. So any violation of this will give 1 unit of violation and take us away. I mean, that C plus will become less desirable because of every such edge violation. And GQ is not a subset of GC minus because there doesn't exist a P for which AQ is less than or equal to PAC minus P transpose element-wise inequalities. Okay. So the real problem with this is the quadratic dependence. This PACP transpose is basically a quadratic function of P. And that's where the mess is. So if we convert the test of isomorphism to a distance, then you can say the distance between GC and GQ, and it's a bar because it's not symmetric, is the minimum over P, AQ minus PACP transpose plus, like take the positive part of that, and the 1-1 norm is basically just a sum of absolute values of a matrix. So edges in EQ not covered by EC contribute to the distance. That's the short form. We can train this using triplet loss if we want. The problem is the quadratic involvement of P. In fact, when P is a hard permutation, this is an autodius optimization called the quadratic assignment problem. And we don't want to go anywhere near it. So one question is, just like in principle, in a passage, every word is influencing every other word. So you could think of it as an adjacency matrix. However, the transformer encoder network somehow turned that into a linear assignment problem. As a direct analog, can graph neural networks turn this quadratic assignment problem into a linear assignment problem? And this seems to work out. So again, in case you're not familiar with graph neural networks, let me just go through a 1 minute of GNN refresher. So a graph neural network has k layers. We initialize a node vector for each node initially, which is at layer 0 for every node U. And then there are these messages which fly around in the network. So what happens? If I am to update the node U's embedding for the next layer, k plus 1, I start with that node's embedding, slap together every neighbor's embedding in the kth layer, form a message using some feed-forward network. I aggregate typically using a symmetric function, although that has its discontents, and then I combine it with its own to give it a bit of an inertia. Is widely used for various applications. There are a lot of unresolved issues around GNNs. We can get into that offline. But apart from giving me at the output, the node embedding at the kth layer for every node, you could think of this thing over here, this message formed between adjacent nodes as a kind of edge representation. You could even form this kind of a message between two nodes which are not neighbors, just to see what their joint features look like. So with that in mind, can we turn quadratic to linear assignment? So the final layer node embeddings are collected into a matrix called capital H. And we also get capital R, a bag of edge embeddings, or you could think of it as node paired embeddings, some of which are edges, some of which are not edges. Different applications demand both of these encodings. So these bags can then be used for a set-to-set linear assignment as with text. In practice, we have found that matching edge vectors performs better than node vectors, probably because they package more information about neighborhoods into them. Small clicks may perform even better. So now observe that our distance function, like the deviation from subgraph isomorphism, AQ minus PSE P transpose sum over IJ, and IJ are nodes here, can be flattened using tensor type notation into, suppose I take all possible edge slots, K, I flatten the matrix into a vector. I take the Kronecker product of P with itself, that's itself a permutation matrix, small exercise, times the vectorization of AC. These are actually the same thing. So this suggests that just like text embeddings, I should be able to write this as sum over edges or non-edges too, the edge representation of Q minus P times the edge representation in C. So basically these R's are nothing but a neural compression of these vecs, right? And old-timer information retrieval guys are thinking, aha, I mean, you mean to say that A is like a term-to-term co-occurrence matrix, and I did PCA on that, and here is the PCA vector for the terms. And yeah, that's it. I mean, word embeddings were actually invented in 1992, not 2013. So exactly, right? That's it, what's going on. So with all this prelude, here is the scare diagram to find subgraph isomorphism. It's easier than it seems. So here's our query graph. In this case, it is a subgraph of GC. And corresponding edges are shown color-coded for convenience. These enter this graph neural network, which does the node initialization and the messaging and aggregation and combination in that layer form. Finally gets those edge embeddings R for the query and the corpus, right? And so those edges basically live in this kind of a space. And so it's color-coded, right? So the orange and the blue edge kind of live in similar spaces. And these two black edges leading to leaf nodes live in similar spaces, things like that, right? Meanwhile, in the upper diagram, you see the corresponding embeddings as well, right? And our job now is to find a correspondence between the edges. Okay. So we list out the edges in both the cases. We pad the edge set, and then we have the Sinkhorn-Knopp iteration. There's a slight embellishment of that called the Gumbel-Sinkhorn network using a Gumbel distribution to seed it. We will not get into that, which finally gives me a permutation between the edges of GQ and the edges of GC. Now, as is required, this permutation looks beautiful with zeros and ones, but of course, in reality, they are all fractional. But from that, we calculate some kind of a distance between the two graphs. And meanwhile, we have supervision data, say whether something is subgraph isomorphic or not. It could be very distant supervision. We may not have judgment about subgraph isomorphism. We might say that this graph contains the query better than that graph, and that's the only supervision we have. It could be triplet loss. But we can backprop all that through this machinery to the Sinkhorn networks parameters as well as the GNN's parameters, fully automatics. So this works out reasonably well. By the way, I didn't want to put any numbers in today's talk. I wanted it more of an ideas talk because numbers get you papers, but numbers very rarely start a paper. Okay. So now I'll come to a generalization which we figured out a year or so later, which is that this form of subgraph isomorphism is actually a special case of a more general form of graph edit distance in an inverted sense. So what's a graph edit distance? You're allowed 4 operations. You can add or delete nodes, you can add or delete edges. And each of the ops has a certain cost. So B plus, B minus, A plus, and A minus. Now find the optimal edit path and the optimal edit cost between G and G prime, with node sets V and V prime, edge sets E and E prime, and adjacency matrices A and A prime. Although it's not always necessary to go that far, you could always pad these graphs up to the other graphs node set, like n plus n prime, so that they both become the same size. And now modulo what your a plus, a minus, b plus, b minus is defined as, you can always find an optimal edit sequence in these bigger graphs. Now let's start with this same hard permutation. So if I now give you a hard permutation between these two padded graphs, that should in a way completely define the graph edit distance, assisted with a plus, a minus, b plus, b minus, but also what is the padded node set in the first graph and what is the padded node set in the second graph. Let's call them W and W prime. Okay. And you probably already have it, but just to make things explicit, suppose P U prime is equal to 1 in a hard permutation. So U is mapped to U prime. If U is padded, but U prime is not padded, then you added a node, so you have to pay B plus. So how do we do that? We include the term B plus times P U prime times W times 1 minus W prime, U prime. Similarly, if something was not padded in the graph G, but it became padded in the graph G prime, then you deleted a node and you have to pay B minus. The nice thing is that these are all very simple expressions, right? W is a fixed constant, and P is the decision variable, and B minus is a system parameter. Now, edges are a little more tricky. So suppose P U prime is 1 and P V prime is 1. So I claim that pi maps U to U prime and V to V prime. Now, should I pay edge deletion and addition costs? Well, it depends. If U V is in E, but U prime V prime is not in E, then you have deleted an edge. So you have to pay the edge deletion cost A minus, and similarly, right? So we can give it in a compact matrix notation as A minus times our old friend A minus. And this completely characterizes the graph edit distance. And once again, if P is limited to a hard permutation, this is hard, this is intractable. But by relaxing it to doubly stochastic matrices and having a neural network learn the family of graphs, you may hope to do better in the average case. So there are many complications beyond this basic observation. The network will generally output soft and not hard permutations. From this soft node permutation, we have to derive a soft node pair permutation to judge if edges are being mapped properly. So S of E prime will be SUV, E will be this edge UV and E prime is U prime V prime. And that will be the product of U maps to U prime, V maps to V prime, or U maps to V prime and V maps to U prime. Because in an undirected graph, it could happen both ways. And although I might have missed it here, that might mean that for the edges, you have to multiply it by half or something like that as an adjustment. Okay. So if you have node representations H and edge representations R, then GED can be, graph edit distance can be entirely characterized by this 4-part function, A minus times the delta edge minus, A plus times the delta edge plus, which depends on only R prime and the edge, soft edge permutation, and then H and H prime and the soft node permutation. That's how it factors. And then we can linearize these deltas using graph neural networks as before. There are further complications. If I don't have enough time, I didn't want to spend too much time here. There are two choices. We first apply the permutation, like here, PH, SR, and then we take the difference. So align and then take the difference. Or you can say diff first and then align. So we'll have the outer sum over edge pairs. Inside we'll subtract the two rows, and only then we'll say, okay, what is the probability that E map to E prime? Think of it as a kind of probability. So it's an expected situation, right? There are yet other possibilities, right? So if you take all these node pairs, there may be actual edges or there may be non-edges. And if both of them are edges or both of them are non-edges, then we should not assess any edit cost. But in practice, because of fractional values, that will happen. So there will be a noise floor leaking into these expressions. And to prevent that, we can do an XOR. So we take the old values here, but we multiply this by this stencil that A and A prime can't be the same. Because if A and A prime are the same in UV and U prime V prime, then there is no penalty. So you stencil it based on that agreement. This is called XOR different. So of course, we have no idea which is going to work better. I don't know about you, but Whenever my students and I come up with like 3 options of coding these kinds of things, we hack sessions up, and we have our initial intuition about which should behave better. After experiment, always is something else, and for reasons we didn't foresee. That's a long story. And so here's the scare diagram for the graph edit distance network. So along the top, I show a structural example. So you start with a 3-node G. We add a node, yellow node. We delete the pink to blue node. Then we add an edge and add another edge, and we get G prime. So the edit cost can be along these 4 edits. To neuralize it, we first add padding so that both of them have the same number of nodes. Then we run this message passing neural networks with parameters theta. That gives me node embeddings. That coupled with the Synchron network gives me node-to-node mappings, soft node-to-node mappings. But this also gives me this edge embeddings using that message, the RIJ stuff going into R. But this P now induces the edge embeddings according to the formula I showed in the previous couple of slides. Yeah. Somewhere around the bottom of this. Yeah, this equation. So S is expressed, edge permutation is expressed in terms of node permutation. And that's what this picture shows. So node permutation induces edge permutation, from which we get the edge add and delete costs. Meanwhile, the original X's along with P's gives me the node add and delete costs. We multiply them by A plus, A minus, B plus, B minus, and we get the graph edit distance. So once again, we can supervise this in a distant fashion, saying these 2 graphs are closer to each other than those 2 graphs. And we can see if it learns to figure out the actual graph edit distance, which we may find by combinatorial methods which are very slow, but which are exact. So what we found somewhat astonishingly is that just doing distant triplet supervision on this network helps our network estimate graph edit distances fairly close to combinatorial solvers. So that seems pretty interesting. Now observe that I'm not claiming there is a foundation network for graphs. All of these are highly specialized. So we are trying to learn from what text encoders do, but in no way are we trying to retrofit text encoding into this game. Yet another concern might be connectedness. So the converse of graph edit distance is maximum common subgraph. Is the exact complement, right? In optimal cases. So here are these 2 graphs, find the maximum common subgraph between. Also extremely useful in chemical design, molecule design, drug design kind of things. So here it has found a large subgraph which is common. Unfortunately, it's not connected. So the upper blue structure is isomorphic to that structure over there. Right? Let's see if this works. This one is isomorphic to that one. This one is isomorphic to that one with some missing edges which don't matter, but they're not connected. So in practice, you probably prefer connected things. If you're doing KG question answering, it doesn't really make sense to report disconnected components from the knowledge graph. Same for molecules. So here, between these 2 graphs, that would be a more preferred common subgraph to report because it's all connected. There's a single piece. So if I blindly try to maximize edge overlap or to minimize graph edit distance, the correspondences may turn out to be in disconnected components, and that's a bad thing. How do I simultaneously discourage disconnection while encouraging commonness in the subgraph? And the answer is we gossip. So how do we gossip? So you can forget about the pseudocode. It's much easier to look at this little cartoon at the bottom. Suppose the orange and the blue are neighbors, the green is not. And we initialize them with 1-hot vectors for each of the nodes. That's why there's the I, x0 is equal to identity. And then everyone exchanges messages with their neighbors and sets their neighbor bits to on and does this order diameter time. Obviously, what's going to happen is that those 2 guys are going to get both their blue and orange set, whereas the green one is stuck with only one. Now, if we take the 0 norm of those vectors, these 2 will get a norm of 2. whereas that will get a norm of 1, and the max will be 2. So the largest connected component here is of size 2. So that's basically the idea. So, and gossiping is eminently neural network-ish, right? It's just another MPNN-ish kind of thing, but it needs a lot of further work to succeed with soft permutations. So because what's happening is that these correspondences are being set up by a soft permutation. So actually, soft edges exist between everyone. It's only based on a thresholding that you can judge what component size you're getting. And the thresholding has to be very dynamic. So that all the detail is in the paper. But it works out well, and we can actually encourage, this is actual runs of the algorithm which prefer connected graphs to others. So now we're getting really brave, right? I mean, permutation seems to give us a lot of things. So what can we try next? Maximal cliques? Why not? Go for the kill shot. So here's a graph. You can see it has a 4-click and a 3-click. Okay. If I write down the adjacency matrix of this graph, I get this. And let's say we add all the self loops on the diagonal. Let's say everyone has a self loop. Now, if some little birdie, an oracle, gave me a P, and I multiplied A by P and P transpose, lo and behold, if P is perfect, it should be able to line up the click on the main diagonal. In fact, if there are smaller clicks, I may demand that all of them lie on the diagonals. Okay. So now the problem reduces to find a search for a good P and then detect large squares on the diagonal. Now, detecting large squares on the diagonal is like computer vision, right? So we should be able to do it with a coordinate-like structure. So that's one view of it. Use a synchron network to propose P's, and then use a coordinate-like structure to search for big squares. Seems to work. There's a second view of finding maximal cliques, which is even more close to subgraph isomorphism, which is, let's generate small cliques, K2, K3, K4, and iteratively test if Kc is contained in my graph. There's a famous Calvin and Hobbes cartoon strip where dad is driving over a bridge and it says limit 21 tons. And Calvin asked, Dad, how do they know this bridge's weight limit is 21 tons? And dad says, oh, that's very simple. They build the bridge, then they drive heavier and heavier trucks over it until the bridge collapses and they remember the weight of the last truck. It's like that. Okay. Hey, it's polynomial time. So, right, so you see K2 is contained in A, and therefore my asymmetric distance will turn out to be 0 if P is right. K3 is contained, K4 is contained, right, given the original graph, up to K4 is contained. K5 is not contained, and therefore I'll suddenly get a jump in the distance similarity function. And it's trivial to detect a sudden jump. Any neural network can do that. So that's our click detector. So these are vignettes of certain tricks we have been playing, starting with this simple idea that we need to compare sets under asymmetry in both the set comparison as well as possible asymmetry in set element comparison in various ways. And we have succeeded in 3 or 4 interesting problems, which are traditionally hard in the worst case. But if you train it with a family of graphs, for the same family of graphs, it does pretty well. And it shows limited adaptation characteristics as well. I'll just rush through one example of graphs with rich features. After all, this is an information retrieval conference. So we're working on this problem of aligning knowledge graphs across multiple languages so that to enrich things into a super KG. So for, again, to familiarize everyone, a knowledge graph has edges, which are like triplets, subject entity, relation, and object entity. And these entities are in principle abstract. They are like opaque IDs like Q937, P19, and Q3012. But if you look them up in Wikidata, you'll find that Q937 corresponds to Albert Einstein. P19 is a relation which is place of birth, and Q3012 is Ulm. But in terms of language, it has manifestations in many, many languages of the world. In English, it's Albert Einstein, place of birth, Ulm. In Hindi, it's this. Although both the subject and object are transliterated, whereas the relation is translated. There's some interesting stuff there. Now, in this setting, suppose I want to judge if the Russian Stolitsa is the same relation as capital of. Turns out it's the case. How do I judge that? So there are pure graph topology-based embedding schemes, which like complex, which will give you an embedding for every entity and the embedding for every relation. Now, again, we could take this single vectors R and R prime, the English vector and the Russian vector, starting with multilingual BERT or something like that, and then say, okay, do these vectors look close enough? And that gives you a baseline accuracy of judging if two relations are the same in two languages. But we got much better results by the following disaggregated approach, which is we characterized a relation by a set which we call the SO set, subject-object set. So what is the SO set of R? It is a two-tuple of all subject-object vectors such that SRO is in the knowledge graph. So just as a word is known by the company it keeps, a relation is known by which entity pair it joins. And let's take their embeddings. Right? And this, and then we compare SO of R and SO of R prime exactly using the techniques I've been talking about. And this can dramatically improve the accuracy of merging knowledge graphs in multiple languages. So to wrap up, we started with single vector query and passage embedding. Then we said that, oh, single vectors are not enough, too much information is being lost, and cross-encoding is too expensive. Multi-vector Colbert gave us a nice sweet spot in the middle by doing this crossbar, and that was the starting point of it all. And Colbert defined this chamfer score, the sum max score. From there, we went to soft permutations and Sinkhorn-Knopp as probably the second output structure after multinomial distributions that come out of neural networks. Then we used graph encoders to contextualize graphs, just like transformers contextualize text. And then using the tricks I outlined, we solved subgraph isomorphism, maximum common subgraph, graph edit distance, max-leak, all of these via some kind of a permutation oracle. Not really an oracle, it's actually fed from the graph's embeddings, informed by them to try to find a candidate P. And then we backprop if P is not good enough. And the whole deal is to try to convert quadratic to linear assignment to make things more tractable as well as backpropagable. But often other gadgets are required to make specific problems work out, and that's where the fun design part came in. So what are the takeaways? Irregular objects call for unaggregated irregular size representations. And this seems to be a settled deal. Right? Let's not try to shoehorn everything into a sequence or everything into a vector, single vector. But matching irregular bags of vectors is more tricky than comparing fixed size vectors. You can only do so much in comparing two vectors. But you can do a lot of different fun stuff by comparing two bags of vectors. In particular, things will generally be very sensitive to the application goals and their losses as soon as you get to set comparisons. Additional task-specialized network gadgets are often needed, for example, the gossip or the other structures around. But it usually pays off in terms of accuracy. It may affect efficient indexing. It does generally affect efficient indexing. So that's an entire area where we can go into and try to attack LSH-like situations, and we are working on that a bit. One thing I left unanswered throughout the talk is, can we take back some of the lessons learned from this graph exercise into information retrieval and text search, particularly with regard to, say, dependency graphs or knowledge graphs? Can we search better because we now know how to find small graphs which match something else? And finally, structured constant prediction in the output space using neural networks still has ways to go. You often heard things like, oh, I use a LSTM encoder followed by a CRF decoder. So the CRF decoder is still needed to keep things constrained properly, right? So, and sometimes, so some people claim that this even has a role to play in hallucination. That it's basically the LLM losing track of higher order dependencies in the far left context. There's a paper with a slightly explosive title by Samir Singh called Barack's Wife Hillary. So you could check it out. They present a better sampling strategy which is like a combination of the usual multinomial sampler of a language model, but also a random walk sampler on a graph to try to address this. So that's what I had to say. Thanks for your attention.
Great talk. I think there are lots of questions, at least a few questions from the audience. You have a question? Yes, start.
So I have one question. So sorry, I only understand first 3 topics till Colbert.
First 3 topics here, there?
Yes, yes.
Okay, all right.
So after that, I'm not able to track. So actually, I'm working with the fire corpus. So I think whatever you explain, it is on English data. So if I want to work in a Gujarati or Hindi. So if we use this Colbert or this bioencoder or cross encoder, so we have to fine tune, right? For sure, because as per my knowledge, there is no models present on fire data or any Indian language. So I have one computation power question, that how much computation required for Colbert or bioencoder that to run that thing, if you able to answer?
Oh, if you're looking for approximate real life numbers, I don't think one needs industry grade hardware to run Colbert at all.
I think 24 GB GPU.
Yeah, reasonable corpora. So, and I've never done it personally, but I hear that 70 billion parameter LLMs can be trained in academia over a week on 2 or 3 A100 class GPUs.
Yes.
But before you jump into all this, another thread of work I have been involved in is that the token dictionaries of multilingual LLMs are extremely skewed in favor of high resource languages. And not only are the dictionaries impoverished in the low resource languages, but also, particularly if you have byte pair like scanners, then there's infinite chances of collision between all kinds of situations. And this is even if you don't have transliteration, which is very common in Indian languages. And so the Hindi he versus the English hi, or the German mit as against the American MIT. You know, it may not bite you all the time. Sometimes it will bite you. So first you have to set up your translingual dictionaries very carefully. And so we have a couple of papers on cheap tricks to include dangerously fragmented LRL tokens. And to a first approximation, if you run a couple of measurements on, so what happens is that as soon as you chop a low resource language long token into shorter tokens, its correlation with almost any desired output will go down because of interference from other languages, right? Other byte pairs. And one can just measure this drop in correlation and then say, let me order the LRL tokens in terms of correlation vulnerability, and then just prevent segmentation of the top 200 most vulnerable LRL tokens. And that's reasonably good. You do have to take care in initializing it and then fine-tuning your preserved tokens now with regard to some task-specific corpus. So once you do that, now we can start talking about search-specific fine-tuning.
I think this problem we face in our track, that is spoken query cross-lingual information retrieval. So we gave the fire data and query.
So what languages are typically mixed in the spoken query?
So spoken query means we have Gujarati, Hindi, Bengali.
Code switched?
No, only first monolingual and cross-lingual both.
Nice.
So maybe we take.
Okay.
Any more question?
I have a question. Yes, it was very interesting when you said that you try to do the soft click, not the soft one, but the click matching problem, right? I tried to do the same, but I didn't use transformers. I was using node vectors. but I found it quite difficult to scale for graphs with large number of nodes. So what were your observations for like?
Yeah, I mean, I don't
these
think
approaches?
we are going anywhere beyond like 30 to 50 nodes.
That's
anytime.
what I saw as well. So compared to like combinatorial optimizers.
Yeah, so in the last couple of NeurIPS ICLR, people are coming up with combinatorial solvers of the branch cut kind of variant where the branches are being guided by neural networks, and that's a very promising direction. So
there are benchmarks, particularly for the click matching problem. And for a large number of nodes, those are like weak down truth. They're not really the strong down truth.
yes, exactly.
Nobody, so it's like the highest that's been found with combinatorial approaches.
Exactly. Before a timeout or something.
Yes, but I found that even with neural networks, it was finding clicks of large sizes, but not close to what you find with combinatorial approaches. Was that similar observations that you made as well?
Yeah, I mean, so particularly because we are also dependent on backprops to train. So the scale issue hits us even faster than just doing inference. That's definitely there. So our main focus has been to be able to backprop into the base featureizers rather than trying to beat the scale of the best combinatorial solvers. Those people have been at it for 50 years.
Any more questions? Yeah, can continue.
So I was wondering about the Gumbel estimator, right? So is that required for the backpropagation, or can we do something other than Gumbel as well for backpropagation?
So the version I showed, which starts with just e to the power and then normalizes, that works reasonably well. We probably don't want straight through. That would be. We can also do that.
Okay, if there is no more question, let's thank the speaker for an excellent
you.
talk again.
Thank you.
So now we have a tea break of 10 minutes. We'll back at 4. So after that, we have an industry talk by Jainam Shah. Or before that, one quick thing. Yesterday, we done a group photo. So if possible, we assemble back to that place because yesterday photos was not good. So we have to take again. So no, yeah. No, many people cut. So and we have a Soman sir and director sir here. So we will take that. Yeah.
Unfortunately, it seems like I have again lived up to your expectations.
You are here to take a picture of me.
मिला? हाँ the pointer works. It works.
My laser was brighter than yours. Yeah, this is mine. Yes, yours is lost. Okay, found it? Okay.
So you from ITM in the first batch of ITM. Oh, that was a long. Which should I use? Oh, we can use one of these ones. Without?
Okay. Okay. Am I audible? Okay. Hello, everyone. My name is Jainam Shah. I'm a manager research engineer at Thomson Reuters Labs. I'm here for industry keynote. My presentation is much of just giving you knowledge what happened in industry overall after LLM hits. So we used to be a company dealing with a lot of content being documents, being sparse data, being alerts coming in from industry, news threads, everything. And those content was kind of aggregated in one place. And we created tools to search over it. We created tools to draft using that content. So that's my major field of working currently. So I am on the labs part. A little about me, I did my bachelor's from India, I did my master's in US, worked in different startups, and the last one I worked in got acquired by Thomson Reuters, moved back to India after the acquisition. So how we work at labs. So we are a team of research and data science skills, engineering skills and design skills because we deliver end-to-end products. So we have a place to experiment. We have a place where the tool converts the experiment into a proper engineering tool and designers to give a great UX experience. And our process starts with the problem like that end user is facing. That end users can be lawyers, editors that we have on our team or people outside TR as well. And then we define the problem and build and deliver. I think this is the new ways of working that we are encountering where the problem is seen first, how an LLM can solve this problem. Just because we have a lot of use cases that deals with generating text, that deals with drafting over the existing data, right? So we first we start working with large language models in it's major part of our job. Team of research scientists and engineers collaborate with SMEs. So we have prompting sessions. I think prompt plays a big role in any LLM implementation. And when it comes to prompt, it requires the knowledge of the domain that we are prompting for and the knowledge of how prompts work basically. So we collaborate with SMEs together to create a prompt. And then once the prompt is there, we start kind of iterating over that prompt again and again in order to get the accuracy that we need. So I think the company believes AI is a tool to transform the current process, making them more reliable and more consistent towards what we want to deliver. This is our basic cycle of working. So we start by understanding the problem, right? Because there are a lot of traditional solutions that we have already delivered. There are classical models that are trained and they are still being trained and delivered and being used by a lot of products that we have. What we start by rethinking what we have done before and how can that be changed using the new approach of large language models and all the other technology surrounding it. And then once we understand the problem, we start gathering the data. We need some data in order to first work with it and then of course evaluate on it. And then once that is done, we start defining where the large language model fits in and where we need a logic being fit into that same process. So it's a mix of engineering problem plus scientists working on different techniques to better generate the data that we need. And then we start with then the next step is of course raw implementation. That can be any place that we need. And we have SMEs in the loop all the time. So all the solutions that we develop, we kind of consult the SMEs. And also in certain scenarios, the SMEs also use different tools that we have developed, be it a
a leaderboard, be it some kind of tools for fast evaluation, so that the process is much more streamlined rather than everybody manually reviewing the content generated every time. And then once that is ready, we create a whole evaluation framework where either it's a LLM based evaluation where LLM is used as a judge, or it's if we have a goal data set, then we go with comparing with the goal data set. And once that evaluation is done, of course, there's next optimizations and deployment. And once that is done, the monitoring stage kicks in. So that's basically how any solution is getting deployed in labs right now. And this is like rethinking of the existing problems that we have and the existing solutions that we have already delivered. How can we make it better? And also maybe reimagining the whole process now, because at certain point where the old solution were deployed, there were limitations to models, there were limitations to how much a model can do, which now have been kind of out of the picture because of the new state-of-the-art models that we are getting. So in the research part, what do? We have a tool generation, which is using LLM tools. We create like workflows because there is code execution, so pre-processing, post-processing, there is LLM calls in between. We need to tweak the configurations of LLM, tweak with the temperatures, tweak prompts. That should be very easy. So we create tools in order to make that execution very streamlined, and it's kind of a DIY. So if you have a use case, you come in, you enter your prompt, you upload your document, and you can get the whole thing working, and the end result, which you can, the next step is evaluate in the same tool. So that is one part of our job. Then we have, of course, a proper model evaluation framework, where right now, like every day, like there is a new model, there is a new version of the existing model, and it's very difficult to keep up with the new models and keeping up with our evaluation leaderboard. So we have created a kind of a leaderboard where if a new model comes in, we quickly are able to evaluate towards our goal data set that we have created and curate that result. So it's easier for our researchers to understand whether to pick up the new version of the model or not, right? And we are working towards building a lot of agents. It seems like a new way in 2025 where agents are acting much like giving much more better results rather than just using large language models for solving all the problems. And a recent thing that we did was a lot of work on meta prompting. So prompting takes up a lot of time when you are like not aware of the whole use case, but you know a gist of it. And then there is SMEs who have a lot of knowledge, but it's really difficult to communicate because they use a lot of jargons because it's legal tech, right, that we deal with. So they use a lot of legal jargons that the developers or the scientists don't understand. So we cannot make them learn both ways. So meta prompting was a tool where the SMEs can kind of describe the problem that they are solving, and we use LLM to generate the prompt, which is called as a soft prompt to start with. And once that is ready, we try and test it out whether it works out of the box. At least for our experience, we have seen it works in a really good fashion out of the box to start with. And then we start refining it, which reduces a big amount of time, which when you start the prompt like from the scratch. And of course, there's fine tuning of language models that we work on, where the data is more necessary and it's more closed towards our own proprietary data sets. So that's the research. The hurdles that we face, legacy technology, right? It's always there in the industry. There is a legacy thing that is working. You don't want to touch it, but you can see a big improvement after like new experiments that you do with the same kind of solutions. So you want to upgrade, but it's very difficult to kind of make people adopt to it, understand how AI works, understand how generating works, because in certain scenarios, they expect it to be very like the same document should create the same kind of document every time I run through LLM. That's not the true statement to put when you work with large language models. So to make them understand that, of course, prompt engineering, I said it's a very vast amount of time goes into prompt engineering. We face a lot of hallucination, inconsistent outputs. We work with drafting documents for contracts, for leases, and a lot of different types of legal stuff. And there is a necessity of following certain format. There is a necessity of being consistent towards a certain format that we need in the file in order to create a proper document. So we kind of curate that using the engineering solution with the large language model. And we are kind of getting close to getting perfection in terms of the consistent outputs. Handling token consumption and pricing. Using language model is of course costly. And when you go over the best model possible, that's when you experiment, right? You try to get over to the best model and see if that yields a better result. And then the next step is, of course, we need to reduce down the tokens. We need to somehow see the pricing where you can use a small language model. Maybe there is a case where you don't need a large language model, or you need something which is less pricier. So we deal with that as well. And then testing model. As I said, like evaluation framework, a lot of work. And we saw a talk yesterday, I think today, on the evaluation as well. I think it's a very major thing in the industry right now, with new models kicking in almost every 2 or 3 months, the older models getting upgraded to the newer version. And you need to keep updated to yourself, like, okay, this is the new model. I need to go train my data and see if it works with it. And if it works, do I upgrade or not? So those kind of questions happen. And then significant engineering work happens. So we start with, of course, language models and the use case. If like there is a source and there is a destination that we want to get into, we see, okay, if we feed in the source and a little bit of prompt, do I get the destination? If not, what do we need to feed into that for as an engineer, right? And also there are like chunking strategies that we work on. We read a lot of papers in order to see which chunking strategy fits best. There are very different kind of XML documents, different types of file that we deal with. They might be like, they can never fit the token length that large language provides. So we always have to chunk over it. But when chunking, we don't want to lose the context. So those kind of things, we work a lot on that. And yeah, keeping the pace with the changing industry and new research that is happening every day. Now here's a shift in the ways of working. Access to, so this is more for engineers and scientists both, but access to large language model for code generation has significantly impacted engineering workflows. As an engineers on my team and other engineers, they spend more time understanding the problem and solutionizing it rather than writing code for it, which is, I feel, is a good plus for any engineer. And we have learned that we should not force large language model on any and all use case. So there should be a vetting process whether this use case makes sense to go for a large language model use case, or whether this can be solved by just rule-based or a short engineering sprint. So that's another thing. And yes, strong engineering knowledge still remains crucial for any solution. I don't think so. The code generation like Cursor or any other tools are kind of replacing Copilot. It's not replacing the engineers, but it gives a really good, like a fast-paced development cycle for any engineer to update an existing code or to go over a code that you have never seen, right? Like there are code that have been written by like 100 different engineers and it's still there in your code base, and it's very difficult to read such stuff. So Copilot really helps in that kind of scenarios. Finding bugs has been very easy now. So those kind of upgrades are happening and shifts like in the ways of working. Roles have been revamped. So we have research scientists, we have research engineers, we have software engineers. They're kind of now merging a little bit into more like an AI engineers, that what we are seeing, and the gap is closing. There's still a difference between those roles, but there is a closing gap between that. And the reason being it is both the sides have to upscale themselves in order to understand the landscape and deliver a solution. So that's interesting part in terms of ways of working. And yeah, it's the adoption that we are seeing now with any experiment that comes in. There are like, we have this paper reading sessions, we have like patenting sessions. So we kind of read the paper and see if it fits into a use case that we are working on and try to implement that into a practical form. Key learnings, I think everybody knows here, like we need to embrace the AI tools. I think it's upgrading our life. It is not a replacement for human, and it's not even a statement I should mention here. More collaboration with domain experts, research scientists and engineers. Before, there was more of a silo working where research engineer used to do the research part, deliver the code to engineers to put it into a tool and deploy it. And same with SMEs used to do their own stuff, document it and give it to the research scientists to experiment. So that has now kind of been more collaborative with the new introduction of AI. And the new roles and skills need to be adopted. As a software engineer, you need to understand how prompting works. As a research scientist, you need to understand how a little bit of engineering skills work. So that's a plus. And yeah, strong foundation of engineering capabilities. I've been asked this question a lot with new code generations coming in, be it Cursor, Copilot, and there are plenty of tools. Is there a still need to learn engineering concepts? Is there a need to learn software engineering? And that question comes up like so many times. And I've experienced it and I've seen it. The people coming in as an intern, if they start with Copilot, they never learn the basics, there is a problem. And you always need that engineering concept background. Like you can never work directly with code gens, because if I give you a code which was generated by something which you have no idea about, it's very difficult to like, it's next to impossible to understand that. So engineering concepts are not going away. You still need to learn it. I think it is just giving you a pace where the repetitive task can go away. Writing unit test, I think it's one of the most boring part of the job, but I think a lot of people encourage writing it and that goes away. So those kind of things are, I think, giving us a pace. So yeah, be prepared for rapid changes and continue. Like the models are changing so rapidly. We have been experimenting. We started with GPT for sure. We have been experimenting with Sonnet 3.5. It's a crazy top to the first, like it has changed vastly. So yeah, it's a big upgrade to each model every time it comes in, and a major upgrade gives us a more deep dive into, okay, let's think again about the solution we did maybe 6 months back. And because of that, any solution we deliver, we try to make it adaptable to the changes. I cannot fit in a solution which is now deployed and I cannot touch it. It should be very adaptable to change the prompt, change the models. That should be very easy to do thing. So yeah, it's not too distant future. AI-driven solution will be a thing in all the industries, and it has started. Like a lot of industries are spending a lot of money into like reforming their current process into AI-driven solution. And this is not just for the tools that they have deployed. This is also for their own ways of working, be it HR reviewing resumes, be it like any other field within the company. They are all kind of enabling their workflows using AI. So that is something that is very, like gives you a real pace in the industry. And emergence of new roles. I recall we had a lot of prompt engineers at some point in the company, and they used to do prompting for us. As I said, now meta prompting has kind of taken away that role, but it's still there. There is a necessity of prompt engineer when it comes to a very specific industry, specific prompts that we have to write. And yeah, continuous evaluation. I think user interface plays a big role. Most of the AI applications you have seen are chat applications, right? You have seen interacting with it as a chat, right? User interface plays a big role because chat was the first thing that was introduced to you as an AI agent, right? But when it comes to implementing in a wholesome fashion of a tool, you need to understand what happened, what was the retrospect behind the result I'm getting. So those kind of reasoning given into a user interface, that helps. Plus, if you get a better result in terms of formatted output, I think chat supports Markdown and stuff, but you don't get like the exact format that you need all the time. So those kind of stuff that I think we are working on to get more end result oriented, where the user interface is simple enough to give you access to AI, but still gives you the result that the older classical tools were giving you. Yeah, that's about it from my end. I will give you a little bit before we get into question, a little bit idea of what Thomson Reuters is doing and what are the tools we are building. I think a lot of people know Thomson Reuters and a lot of don't. So we are into legal tech. That is one domain of Thomson Reuters, and we deal with a lot of content. And with content, because I'm saying this abstract word content is because we have different kind of cases, different countries that we deal with, country specific use case that we deal with. But our major tools are Westlaw, and then they are for searching old cases. They are for, there is a drafting assistant that we have, which helps you draft contracts, that helps you draft leases and all the other kinds of legal documents, right? And that assistant is like a word add-in. So you have a chat interface. You type in something that this is what I'm trying to draft, and it will start writing it for you. You can continue chatting with it or modify the document at the same point, and it will give you more. And it's not just large language model, it's a mix of engineering skills and large language model, which gives you a way of chatting with it, but not like in a more predictable way, that it is in the context of drafting. So that's the major hero of the tool, drafting. So those are the things that we kind of work and support in as part of TR Labs. So yeah, that's about it from my end. Any questions?
So I have a question. Like you mentioned that you make cost-effective models earlier. So suppose there is a cost A, then what factors do you consider while training or preparing a model that okay, it has now reached that particular limit and now we have to deliver it? Like what goes behind the scenes to make a cost-effective model?
So to make a cost, so our first, of course, the experiment starts with, there is no cost barrier. We go with whatever best we can, because accuracy is the first go for any experiment. That's our target. Once we receive that accuracy, and if it exceeds the cost that was planned for this, so cost comparison goes with what the traditional tool was costing us and what after introducing LLM costing us, right? And if it is costing more, but it is still more accurate, then it is worth it, right? But if it is costing more and still less accurate or equivalent to it, then we need to rethink about reducing the cost. So that's where the cost estimation comes in. And certain tools that we had previously did not, like they were not at par in terms of optimization. But with large language models, we are getting that. So we are okay with increasing the cost of that tool because it gives more accuracy. And I think legal deals with, like they need more accuracy rather than the cost part to it, because they are already saving a lot with these tools in terms of human effort, right? Because any tools, of course, require humans at the end to review it, but it is still reducing the human effort overall. So the cost factor comes in after the experimentation. The first goal is to get the best that is possible in the industry, and then going towards, okay, if in this, like if I'm making 10 LLM calls for a certain use cases, if the first 3 can be done through a smaller language model, or first 3 can be done through something much cheaper than the latest model, then we opt for that, and then we convert the rest into whatever it is. So that's how we distribute the cost.
Yeah, hello. So thank you for the talk. So see, I also come from the industry. So in this transformation shift, do you think so I'll ask a cover question first. Where do you deploy these models? Are they outside of the Thomson Reuters environment or only inside the Thomson Reuters environment? And now the core behind that question is, don't you hit a hurdle of licenses? Like, I mean, I can tell you, if you use this sentence embeddings, all mini LM L6 V2, if you see the license at the face value, the model is licensed with an Apache or an MIT, which is a copyleft. So it's allowed.
Yeah.
But if you see the data on which it is trained, lots of that is CC by this thing. So don't you hit any hurdles of licensing while you deploy? So where does the IP control, or like, isn't that going to be one of the major friction points in this shift?
It will be for at least the one that I am working on are mostly internal. So as you said, do we deploy outside? We don't. It is mostly deployed internally and being used by the lawyers and editors that are on our team. So it is for them, and the whole tool suite is for them. For the products that we have customer facing, we have a whole compliance team dealing with all this stuff. So they take care of how do we deal with deployment of this. But I think even country specific, there are different rules, right? So that's why we have a team that interacts with the data that we are getting from, or whether it is proprietary data within TR, right? If it is our data, then we keep it on our, of course, it is either on-prem or it is at least in the region of the cloud that we are in. So that's how we kind of save our data. But as you say, like most of the work that we do is for the internal tools to pace our internal editors to do their work faster, right? So that's your, yeah. Oh, we have both. We have both. So certain solutions are RAG based. We do RAG, re-ranking and all that stuff on certain use cases. It's, as I said, like it's a mix of, depending on the use case, we either opt for, if the data corpus is really big, we need RAG. So we go for that. But if in certain use cases, it's more like there is a document and there is this data that might affect that document, you need to rewrite this document, that kind of simple use case, right? In that case, I don't need RAG. I can go with LLM and some engineering solutions along with it. So that depends on the use cases I'm trying to solve. It's a very good question. So for a large scale data, at least for one experiment I can talk about, I worked on. What we did is we used 2-level RAG and re-ranking through LLMs. And it was, when you say like repetition of the data, the cleanup happens right before we even embed it. So if we see a repetition of case, so we have certain algorithms in place where if I put in that data, it filters out and then it does the embedding. So there is a pre-process that is happening even before the embedding, so that we don't pollute the embedding with a lot of data, which is just a repetition of the same thing. So we do a pre-processing, we clean up that data, then it goes to the embedding and then we query that. So there is no issues with that. But if it is a very big corpus, yeah, we need to do there are a lot of approaches, and this is more coming from the scientists than me, but they do 2-level RAG. They have LLM re-ranking stuff implemented. I have also seen certain problems where they try to get like more documents rather than like RAG, you can retrieve any. So they get like 50 documents, summarize it, then rewrite the question that was asked, and that send it to LLM, then again send it to RAG, and then go back to LLM for re-rankings, that kind of process. Yeah.
So I want to ask, do you guys use any framework like LangChain in your projects? Because it may face deprecation issues while deploying the projects.
Yeah,
So
we
how-
don't. We don't. We started with it when it was launched, but yeah, we avoid now. Yeah. It was an easy access to start with for the developers to experiment, and then we started building our own framework, so we don't have to use something that is not reliable to stay. Mhm. Yes, yes. So in certain use cases, that the one that I was telling, the latency was not the problem. They wanted accuracy. So it depends on the customer. If they are more fond of accuracy, they might have to deal with latency a little bit. But if they are okay with a little bit less accuracy, then we can. So what we have done in certain solutions is we have given an option for more advanced search and a regular search. And for the quick retrievals, you can go for regular search. But for more advanced and like, so even the summary generation, so any cases I'm searching, right? I need a summary. That's what I'm going to read. I'm not going to read the whole document at first go. So I need a summary. So even summary generation can be quick as like in milliseconds, and it can be like a minute long process to generate it, right? So we have curated that, that if like depending on the requirement, we generate the summary. So it's in the user's hand whether they want a very accurate and things that were like, we also give options that these are the XYZ things that I want to be part of the summary. So they can include that as part of it. And if that's the requirement, then we curate that summary as per that.
So basically you have mentioned that you are working with legal documents, but that's a very niche domain, right?
Yeah.
And then one of the problems is that the documents are quite long. They're quite expository in nature. But most of the LLMs would have been restriction of, 4096 tokens or 8192 tokens. How do you overcome the barrier? Is it by segmenting those documents into smaller chunks? And while you do that, do you that segment arbitrarily? Or is there an intelligent algorithm that you use to don't segment at the middle of a topic, but then do something like a more smarter topic-based segmentation? Is that something that you do?
Yeah, so we have a multiple process of chunking strategy. One is, of course, page level chunking, which is mindless. You just chunk over the page. There is an overlapping page chunking strategy. These are all papers that are already published, and we are kind of implementing it in our use case. There is a chunking strategy where the context is on page 1 and you are sending a chunk of page 9. So what we started doing is we start with page 1, page 2, page 3 as a chunk, and then summarize it and send it with the next chunk that we send. And this is only possible with a longer context model like Sonnet 3.5 gives 8,000 limit. Gemini gives much more. So in case scenarios where we need a much more context, then we go with the model that supports that. But there is still a limit. There's no bound to that. So, but yeah, that's different kind of chunking strategies that we use.
Have you tried to measure the effects of the intelligent chunking versus if you don't do that?
Yeah, we did. It makes a big difference. A very big difference, yes.
So yeah, we are talking about this chunking part, and I also went through this chunking problem, right? So we were working with this FLAN-T5 model, which is a very smaller context information that can be provided. It's like 512 tokens. So the paper that I was working on, the PRP paper, that actually showed that they are providing 2 documents and a query to the model and asking the model which of these 2 document is relevant to that particular query. And the documents will be of larger size and will easily exceed this 512 tokens. You are providing 2 documents at a time. And what they have done is basically they just took 200 tokens of each of the documents and provided. So whenever there is a 200 token, it doesn't consider even if it is a half word or a full word or a full sentence or whatever. So they're not considering any sentences. So this is how they are doing. So what I have done in evaluation of this is that I have provided, for example, I have this document and I summarized that document so that it becomes a shorter version of it and pass that document to that. And after many kind of changing this, I found that the cutoff actually works better than any kind of summarization or anything. And also that is also what they have done in the paper also. So
I missed that part. What was the comparison between the 2 documents?
So there is a query, there are these 2 documents, and the model is asked to tell that which is more relevant of these 2 documents to that query.
Okay.
So the model has to output either A or B, for example.
So the cutoff was from the first page anywhere the 200.
So it is from the first token to 200 tokens. So wherever that 200 token is reached, it cuts off there.
Oh, wow. And it worked better?
It worked better than summarizing or even,
Okay.
yeah.
But your documents had, like usually some documents will start with title and all that on the first page itself. And then the text starts from the page.
Yeah, so
towards-
this is only a passage kind of thing. So
Okay, it's a
there is no-
passage level.
no-
Yeah,
no title.
then it makes sense. Yeah.
Taking over website, just because of this website of VIC, and it is created chatbot from the account. So there are multiple pages, and in a graph pages that are very structured. So what we initially when for the change the static function of the which comes overlap, but we created this problem. There was one problem that let's say suppose in a documentation field, there is a title, supported countries, and there is a list of all the countries in a website. So let's say suppose if you do a static country, let's in between of the list is cut out. In the second list, in the whole term there is a list of countries.
Mhm.
You don't have information what exactly is mean. Let's say suppose the user asks the query, does some country means start with Z or X, suppose is a supported country or not. And the LLM don't have the information whether it's supported or not. Whether you have the overlapping or not, that also is relevant. So we also to tackle this problem, we combine the approach of hierarchy something plus semantic something. So it's not the like there is a maximum context of 4,000 characters, but we can paragraph and the 3,000 characters from the butter and consider description. So that means paragraph is blank. So that's what.
I have a question to that. So was that use case more like you parse a website, you have that data, and now you can ask question, right? Any reason for not trying RAG? Oh, okay, it's RAG only, but you did the chunking technique. Okay, makes sense. Yeah. Okay.
So, even this entire pipeline where you are using multiple LLMs like how hard is it to maintain a consistent output given the same sample? So how hard is it to maintain a hallucination-free system? Like suppose you are asking it to give output in a particular format, and suddenly like it's working, and then suddenly it starts hallucinating.
Yep.
Pipeline just goes down and find that there's an input and it's time.
It is. So hallucination is a whole different topic. We have a team working on it for sure. But just to give you a little bit of idea, what we have been trying to do is for any workflow, a certain tokens are expected to start with. So if I am expecting an XML output, right? So I know it will be a bracket that will start with, and it will have certain elements that I'm expecting. So if something, this kind of weird thing happens, we have a retry mechanism like a normal engineering solution has. So we try to catch it as much as we can through engineering solutions, but getting a constant output from an LLM is way difficult. And like it has been consistent, like over the time I was discussing with him, like over the time with the newer models, it is much more consistent. But I'm hoping that the more new models come in, there will be more predicted text that, okay, this is what I'm expecting. I recall working on a solution where I needed an HTML output. So I was working on using vision model to take the snapshot of the page and give me an HTML of the page so that I can get the exact format of that page. So I can later convert that HTML into back to PDF, right? That was the use case. To get just the HTML was a very difficult task for 3.5. And then when we get to Sonnet model, I think it just eased down, like just upgrading the model eased down that task. And Sonnet has a lot of like input parameters where I can say like start with a bracket. Then it will always start with a bracket. Or else you'll receive like here's your HTML and then the HTML, right? That it stopped doing it. So those kind of problems will be able to overcome easily with the newer models. I'm hoping for that. But yeah, hallucination is a thing. Like it takes away a lot of time when it comes to that, and it's very difficult to detect and retry it. So in certain scenario, you just rerun the whole workflow. But yeah, it's like for searching stuff, it's very simple. But for certain use case where you need a format, right? You're expecting an output. That's the part which is very difficult. Okay. Thank you so much.
So whoever is there in the invitees of the steering committee meeting are please come to the CEP conference room. And I will go there. So yeah, so please follow me over there. And we have a banquet at 7:30 p.m. at the Fern Residency, which is in Sargasan. So for participants, they can take an auto, Ola auto or Uber, anything. It's like 1.5 kilometers from here only. Yeah. We'll share it over email as well.